Good morning, Owen. Can you hear me? Okay, I saw the thumbs up. If you could please make Usia Bonga and Anita co-chairs and Unomfundo Kabuza as well. In the meantime, Sia, I've enabled your mic and your camera. I've done the same for Tamara as well.
Okay, so can you hear my audio now?
Yes, I can.
Oh, all right, thank you very much. So good morning, everyone. So I hope you settled in very well. So we're gonna start very shortly. So today we're going to be talking about geometry of straight lines for grade 8 and grade 9. And then the lessons from grade 10 to grade 12, we'll be talking about trigonometry. So today I'll be sharing this session with Ms. Anita Tamara. So Anita, are you maybe ready to share your screen in your video?
I've shared my video. Can you not see me?
Okay, I can see you.
Yes, I'm around.
Okay. So maybe before we start, so for those that are online, so I want you to just go to Google. So I'm gonna share my screen just now. So please, if you can go to Google, just type in Mthethwamatics. So if you type in Mthethwamatics, so this is the website that you'll see, and then you click on it. So click on it if you are using your smartphone device, but even if you are using your laptop, it's still the same process. And then you go to your top right. So, and then you join the mailing list. So if you join the mailing list, so you're gonna put your name, the name, so your email address, and maybe some details about you. So for example, you can just specify whether you're a parent, a student, or if you don't wanna say. So by joining our mailing list, so you'll get in touch. So whenever we have something happening in Mthethwamatics, so you'll be the first one to know about all the events that we do host. So even things like teaching the nation, so you might be the first person to know all about those things. So and then there are also other things that you can just check on the Mthethwamatics website. So some career guidance and the things that we do on a daily. So you can also follow us on Facebook, Twitter, and all those platforms. So just Google Mthethwamatics, so you'll find all those things. So now I think Anita, are we ready? So do you see Miss Kabuza?
Still looking for her.
So okay. So also just to add, so today at 12, so from 12 to 12:30. So please join in again. So we'll be having some lucky draws and competitions. So Miss Anita will ask you some questions where you'll win some prizes. So some of the questions that we'll ask are maybe the things that we talked about here in these lessons. So if you are doing grade 10 or grade 8, so please come back later and please take notes on everything that we mentioned today so that you can win some nice prizes.
Yeah. Siyabonga, I can't see Miss Kabuza. I don't know if it's me, but I can't see her.
Let me also check. So yeah, so maybe let's just give her just some few minutes. So then we're gonna start shortly.
Yeah. Have you also checked?
No. I'm trying to check if I can get her on a call.
Oh, okay. But this time we'll also just give grace to other people to just join in.
Okay, all right. Thank you very much.
I think Miss Nomfunda Kabuza is in now.
Oh, okay. All right.
I think she's
Very
in.
good. Oh. So can you check if she's a host now? So
Oh, okay. Let me just quickly check. I think she's in as a guest. Can you get assistance in making her a host? I think it's sorted now.
Oh,
Yeah.
okay. So Miss Kabuza, if you can maybe hear us, you can just say
Yes,
Oh, okay.
Guys, I
All
can
right.
hear you.
All right. Thank you very much.
I think her audio is quite low, or is it me?
I think I can maybe I can hear it.
Properly.
So maybe yeah, I can hear it properly.
Oh, okay. That's fine.
Yeah, so I think now we can start. So welcome learners and parents. So as stated that today I'm hosting, my name is Mthethwamatics, and I'm hosting with Ms. Anita. So just stay tuned for some nice presents later on. So you see that beautiful t-shirt that Anita is wearing. So you might win. Yes. So you might win some nice prizes like that. So if you pay attention or even ask on the chat box. So we're just gonna randomly select the winners. So I think Ms. Kabuza, you can start maybe sharing your screen so that we can see if you can share. And then we're gonna introduce you shortly just to start. Okay. So I think we are on the right track, Anita.
Yes, we are. We are up.
Yes. So today our teacher for grade 8 and grade 9, so we'll be talking about the geometry of straight line, is Ms. Nomfundo Kabuza, who's an academic at MUT, so also known as Mangosuthu University of Technology. So Nomfundo, over to you.
Thank you. Thank you, guys. Am I audible?
Yes, you are.
Yes.
Oh, thank you, thank you. Okay, guys. My name is Nomfundo from MUT, and I'm gonna be teaching geometry of straight lines for grade 8 and 9. This is more of a continuation from Dr. Dubazane's lesson from yesterday, also for grade 8 to 9. So it's more or less the same, but it's a continuation. Okay, so let's start off with angles, like the definition of an angle. What is an angle? It's a figure or a geometric shape formed by two rays meeting at a common endpoint. What do we mean by that? It's a figure formed by two rays. So which means the ray is going to be, let's say this is the first ray. So we call this ray an arm. And then let's say this is from O to A. And then these are two rays, they say they meet over here at O. And then let's say this is B. So where they meet, the endpoint is called vertex. So it's called vertex. This is also an arm. Okay, so over here, this is the definition of an angle. It's an angle. So this angle, we're going to call it angle O, or angle AOB. So this is the angle. So we have different types of angles. First off, let's start with an acute angle. What is an acute angle? Let's say we have this part over here. Let's call this, okay, let's say this is an angle that we are looking for. This is called an acute angle. An acute angle. Why? Because it's from 0 and less than 90 degrees. So if it's from 0 and less than 90 degrees, which means this angle over here is going to be called an acute angle. And then another type of an angle is called right angle. Right angle, let's say we have over here, let's say this angle over here is 90 degrees. This part over here means 90 degrees. This part over here means 90 degrees. So this angle here from 0 up to 90, if it's exactly 90 degrees, then we call that angle right angle. We call it right angle. Why? Because it's exact 90 degrees. So it's called right angle. Yes. And then we have another angle called obtuse, an obtuse angle. An obtuse angle, it's somewhere, let's say we're moving from 0 degrees. Let's say it's more than 90. So, but less than 180. If it's less than 180, but more than 90, then that is called an obtuse. An obtuse angle. So this angle over here is called an obtuse angle. Why? Because it's greater than 90, but less than 180. Another type of angle is called a reflex angle. Let's say we have something like this. Let's say we have an angle over here, an angle from, let's say it starts from 0 up until over here. So it's more than 180. It's more than 180, but less than 360. We have 360 over here. So this angle over here is called a reflex. Is called a reflex angle. Another type of a reflex angle, it could be somewhere over here. It could be somewhere over here. This is 0, and then this is 360. It's still a reflex angle, as long as it's greater than 180, but less than 360. And then the normal one is called straight line. Straight line. Let's say we are moving from 0 over here, 0 degrees up until 180. So over here, if we have a straight line, this is called a straight line angle because it's exactly, so it's called straight line angle. Why? Because it's exactly 180 degrees. If it's exactly 180 degrees, then it's called a straight line angle. And then another type of an angle is called a full rotation. Full rotation is somewhere, let's say we have 0 over here as well as 360. Let's say this is our point over here. Our angle is moving from 0 up until 360. If the angle is moving from 0 up until 360, then we call this full rotation. Full rotation angle. So these are all types of angles. Then let's move forward. The classification of triangles. These are information that you're going to use. This is just a recap. This is just the information that you need to know before moving forward. So classification of triangles. We have different types of triangles. The first one, the normal one, the one that I think we are all used to, is called an equilateral. An equilateral is when all sides are equal. Equilateral is called equilateral triangle. All sides are equal. So these lines over here means all sides are equal. As well as the angles over here. The angles over here are all equal because all sides are equal. They are all equal. They are all 60 degrees. So this is an equilateral triangle. And then another parts of triangles, isosceles, where we have two sides equal. Let's say this side over here and then this side over here. If both these sides are equal, then this triangle is called an isosceles. An isosceles triangle. Two sides are equal. Two sides are equal. And then another type of a triangle is called a scalene. A scalene is where all three sides are not equal. All three sides are not equal. Let's say over here, let's say I'll use this, and then by these lines, I'm saying these all three sides are not equal. So it's called a scalene. So no sides are equal. No sides are equal. So we're only talking about sides, classification of triangles, but taking a look at only sides. So let's classify them using their angles. Let's classify them using their angles. We have a triangle called a right angle triangle. So this triangle is something like this. So if I post this part over here, I'm saying this is 90 degrees. So if we have 90 degrees, if one of the sides is 90 degrees, then that triangle is called a right angle triangle. So this type of a triangle is called a right angle triangle. Why? Because one side is equal to 90 degrees. And then another triangle that we can call an acute triangle. This is called an acute triangle. Why? Because all three sides over here, let's say this is theta, and then let's say this is beta, it's an angle, and then let's say this is A. So all these angles are less than 90 degrees. All these angles are less than 90 degrees. So we call this triangle an acute triangle. Why? Because all angles in this triangle over here are less than 90 degrees, acute. Another type of a triangle is called an obtuse. An obtuse is something like this. Okay, let's say this an angle over here. This angle here is an obtuse, which means if it's an obtuse, which means it's greater than 90 degrees but less than 180 degrees. So one of the sides it has an obtuse angle, which means it's more than 90 degrees and less than 180 degrees. So that's why it's called an obtuse triangle. It's called an obtuse triangle. Okay, so another information that we need is going to be the theorems of triangles. So the theorems of triangles, let's start off with A. A says the interior angles of a triangle add up to 180, which means the sum of the interior angles in a triangle is equal to 180. So let's say we have this triangle over here, and then let's say we have XYZ. So this theorem says the interior angles, which means X plus Y plus Z is equal to 180 degrees. So is equal to 180 degrees. And then another theorem for B says the exterior angle of a triangle is equal to the sum of the opposites. What does this mean? It means, let's say I have this triangle over here. I have this triangle over here. And then let's say I'm subtending this over here. Let's say I have an angle over here. This angle, let's call this X and Y, and then let's call this Z, and then let's call this W. This part over here says an exterior angle, which means W. An exterior angle of a triangle is equal to the sum of opposite interior angles. So opposite interior angles are X and Y. So which means W is going to be X plus Y. let's say over here we have, let's say, let's use this side over here. Let's use this side. And then let's say we are looking for this angle over here. We're going to call it, let's call it A, this angle over here. So this rule says that in order to find A, this angle over here, in order to find A is equal to the sum of the opposites interior, which means A is going to be X plus Z. Let's hope we are still together. So for number C, another theorem says in an isosceles triangle, the angles subtended from two equal sides are equal. What does this mean? It means that an isosceles triangle, it's a triangle that has two equal sides, right? Let's say this side is equal to this side, and then let's say this is AB, and then the other is AC. So this theorem says that if AB is equal to AC, if these sides are equal, then which means the angle B is equal to angle C, which means this over here is going to be equal to this angle over here. We can call this angle B or angle C, or you can call it angle ABC, and then an angle for B, and then or you can call it ACB, and then over here, which means these angles are equal. And then let's move on. The key concepts, information that we're gonna need. Information that we're gonna need for number one. Number one says vertically opposite angles. Vertically opposite angles are angles opposite each other when two lines intersect. When two lines intersect, it says, let's say this line over here is intersecting with this line over here. So let's say we have an angle here. Angle A is going to be angle A and angle B. These are two vertically opposite angles. These are two vertically opposite angles. And then the rule says here, vertically opposite angles are always equal, which means it says A is equal to, angle A is equal to angle B. Let's say we have another angle like AB, let's say C and D. C is vertically opposite to D, which means angle C is going to be equal to angle D. Even if you find something complex, like let's say over here we have this part over here, and then we have this part over here, and then let's say this is A, B, C, D, E, F. The rule says F is vertically opposite to C, which means angle C is equal to angle F. And then A is vertically opposite to D, which means angle A is going to be equal to angle D. And then B and E are vertically opposite, which means angle B is going to be equal to angle E. So for number one. And then number two says the sum of angles that are formed on a straight line is equal to 180. Or adjacent angles on a straight line add up to 180. So this rule says that the sum, let's say, angles in a straight, this is a straight line, right? Because we are moving from 0 up to 180. So which means if let's say over here I have an angle A and then an angle B, they are both in the same straight line. They are both in the same straight line. So which means the rule says the sum of angles in a straight line is equal to 180, which means A plus B is equal to 180. They are adjacent. And then another rule would say, let's say even if we have three angles, if we have, let's say, AB, let's say over here we have an angle, and then let's say we have C over here. So let's say this, we are looking for this angle. They are still all in the same straight line. Since they are still all in the straight line, the same rule applies, which means angle A plus angle C plus angle B is going to be 180, the sum of all angles in a straight line. And then another rule says, okay, two angles whose sizes add up to 180 are called supplementary angles. This parts over here, angle A and angle B, are called supplementary angles. Supplementary angles because they add up to 180 and they are still adjacent. But supplementary angles, they can be found by saying, let's say, it's as long as the total of 180, they are called supplementary angles. For example, let's say over here, let's say I have an angle, let's call this 60 degrees. And then another angle, let's say over here, this angle, let's call it 120. Let's call this 120. So the sum over here, since 60 plus 120 is equal to 180. These are still called supplementary angles, but they are non-adjacent. They are non-adjacent. As long as they add up to 180 degrees, they are called supplementary angles. And then for number three says angles around a point add up to 360. Angles around the point add up to 360. Let's say over here we have 0 and then we have up to 360. Let's say this is the point over here. This is the point over here. And then let's say these angles. We have these angles. We're gonna call it, let's call it, okay, we can. Let's use this simpler example. Let's call this A, let's call this B, let's call this C, and then let's call this D. These angles, they are all around a point, this point over here. So which means the total for these angles is going to be 360, which means A plus B plus C plus D is going to be 360. Okay, let's move on to number 4. Number 4 says two lines form an angle. When two lines form an angle 90 degrees, we say the two lines are perpendicular. When two lines form 90 degrees. So over here, let's say we have this part over here, this line over here. Let's call this line A. Let's call this line A. And then this part over here is AB. This line is AB. And then this line over here, let's call it DC or CD. So let's say they meet over here at 90 degrees. This part over here means 90 degrees. If this is 90 degrees, which means this is also 90 degrees. So as long as we have 90 degrees over here, which means the line AB is perpendicular to the line DC. This part over here means perpendicular. As long as we have 90 over here, then those lines they are called perpendicular lines. I think from this information we can do few examples. Examples over here. The instruction will say solve for the unknown and then give reasons for your answer. Solve for the unknown and give reasons for your answer. Over here, the first thing that we can notice is that we have a straight line. We have a straight line. This is a straight line over here. This is a straight line. Since we have a straight line, which means the rule says the sum of angles in a straight line, 2x plus, this is 90 degrees, plus 90 degrees is going to be equal to 180 degrees. So which means then we solve for x. X is going to be 180 minus 90 and then divided by 2, which we're going to get 45. So we must always state a reason. The reason over here says angles in a straight line. Angles in a straight line. There's another rule over here. There's another property that you can use. There's another property that you can use over here. Over here, since this is 90 degrees, since this is 90 degrees, so which means this side over here is going to be 90 degrees also. It's going to be 90 degrees also. Then just solve for x, because this, if this is 90 degrees, then if this is 90 degrees, then this also is 90 degrees. You can say 90 divided by 2. And then for example number two, what we notice over here, all these angles are in a straight line. All these angles are in a straight. This is a straight line over here. This is a straight line. So which means we're gonna say 45 plus x plus 40 is equal to 180. The sum of the angles in a straight line. Then we solve for x. Our x is going to be 95. Guys, please double check if my answers are correct. Sometimes I make mistakes using a calculator. And these were straightforward questions, examples. So example number 3, we can use a property. Example number 3, we can use a property. Because what we can notice over here is that this part over here is vertically opposite to this part over here. This angle is vertically opposite. And then the rule says, which means x is going to be equal to 30 plus 50. And then which means x is going to be 80 degrees. So the reason over here, we're going to say vertically opposite angles, vertically opposite angles. And then for number four, I think we're going to need to apply the same rule, because what we can notice over here, y is vertically opposite to this part over here, to 1/4, which means y is equal to 1/4. And then another thing that we can notice over here is x. X is vertically opposite to 25. Since it's vertically opposite, which means x is going to be 25. So the reason for both x and y is going to be vertically opposite angles. Vertically opposite angles. And then for z, find the unknown. Z is in the straight line, which means over here, x, we do have the value of x. X is 25 degrees, right? So which means z is in this straight line over here. Z is going to be over here, z. So which means for z, which means we're going to have x is 25, which means we have 25 degrees plus 140 degrees plus z is going to give us 180. And then we solve for z. Z is going to be 15 degrees. And then another example is example 5. I think it's more or less the same. Example 5 is more or less the same, because over here we can notice over here that these angles are in a straight line. Y and 1/4, they are in a straight line, which means we're gonna say y plus 1/4 is equal to 180. Angles in a straight line. Angles in a straight line. And then y is going to be 40. And then if y is equal to 40, then this part over here says y, which means these are equal, which means over here we're going to have 40. So once we have the value of y and then we have the value of this part over here, 110, we can also notice that we have a straight line over here. We have a straight line from here up until here. This is a straight line. and then which means we're gonna have to use the same property, the sum of angles in a straight line. And then let's move forward. The information that we're gonna need also is parallel lines. What are parallel lines? When a perpendicular distance between lines is always the same, we call the two lines parallel. What do you mean by when a perpendicular? We mean when a perpendicular distance. A perpendicular distance, let's say we have these lines over here. We have this line over here, and then we have this line over here. Perpendicular distance is going to be this distance over here, and then this distance. If we have the same distance from here to here, the same distance, which means these lines over here are parallel lines. We call them parallel lines. Normally we use these parts over here. Let's say we have, this is AB, and then let's say this is CD, and then which means the line AB is parallel to the line CD. And then what's more, this we're gonna need a transversal line. What is a transversal line? Let's say we have two lines. Let's say we have two lines. They can be parallel lines or just normal lines. Let's start off with just normal lines. This distance over here is not equal to this distance over here, which means these lines are not parallel. So a line, if I have a line over here that crosses at least two other lines, this line over here is called a transversal line, because it cuts at least two lines. But over here, for a transversal line, we're going to use it more for parallel lines. Let's say we have this part over here. Let's call these lines parallel. These arrows, if I have two arrows over here and I have two arrows over here, I'm saying these lines are parallel. And then let's say we have a line over here. This line over here is called a transversal because it cuts over here. And then if these lines are parallel lines, and then we have something called corresponding angles. What are corresponding angles? Corresponding angles are angles that lie on the same side of a transversal and are in matching positions. What do we mean by that? We mean like, let's say over here, this line over here, this angle over here, and then this angle over here. The angles over here are in the same side of the transversal, and they are in matching positions. They are both below this line. They are both below this line. So we call them corresponding angles. Another example of a corresponding angle over here, we have this angle over here. This angle over here, and then this angle over here, they are corresponding because they are in the same side of a transversal line. So they are in the same side, as well as this part over here, and then this part over here is corresponding, corresponding angles, as well as this part over here, and then this part over here. They are called corresponding angles. And then another example, another term that we need to recall is alternate angles. The statement says alternate angles lie on opposite sides of the transversal. Let's say we have a transversal. Let's put the line maybe like this, a transversal. And then over here, this angle over here, this angle over here, and then this angle over here. These angles are called alternate angles. Why? Because they are on the opposite sides of the transversal, but they are not adjacent or vertically opposite. Another example of alternate angle. Alternate angle over here. This part over here, and then this part over here. These are alternate angles. Another term that we need to recall is co-interior angles. Let's say we have this part over here, parallel lines, let's say, and then we have a transversal line, and then the definition says co-interior angles lie in the same side of a transversal and between two parallel lines to be specific. So which means this part over here, this angle over here, and then this angle over here. These are called co-interior angles. And then this part over here, this angle, and then this angle. These are called co-interior angles. I hope we are all still together. And then, so for A, if parallel lines are cut by a transversal, the corresponding angles are equal. Then we have rules for corresponding angles, alternate angles, as well as co-interior angles. Let's start off with the corresponding angles. So let's say we have this part over here, and then let's say these are parallel. And then we have a transversal over here, and then let's say we have A, B, C, D, and then we have E, F, G, H. This rule says if parallel lines are cut by a transversal, corresponding angles, they are equal. Corresponding angles are equal, which means this angle over here and then this angle over here, D and H, they are corresponding angles. So which means angle D is going to be equal to angle H. They are corresponding. And then this part over here again, B and F, they are corresponding, which means angle B is equal to angle F. As well as A and E, they are corresponding, A and E, as well as C and G, they are corresponding, which means these angles are equal. And then in alternate angles, if parallel lines are cut by transversal, the alternate angles are equal. Two parallel lines, let's say this part over here. Let's use the same example. Let's use A, B, C, D, E, F, G, H. Let's use the same example. So alternate angles. Remember this alternate angles are this angle over here and this angle over here, which means it says alternate angles are equal and these lines are parallel. So which means angle C is going to be equal to angle F, which means angle D is going to be equal to angle E. They are called alternate angles. Alternate angles are equal. And then for co-interior angles. Co-interior angles, let's use the same example again. Let's say we have two parallel lines and then we have A, B, C, D, E, F, G, H. So for co-interior angles, it says if parallel lines are cut by a transversal, the co-interior angles are supplementary. Remember, supplementary means the sum is 180. The sum is 180, supplementary. So which means the co-interior is going to be this angle and this angle. These angles are called co-interior angles, which means C plus angle C plus angle E is equal to 180. And D and F are co-interior as well. So which means the sum of angle D plus the sum of angle F is going to give us 180. And then okay, Siyabonga, I'm still touching the stylus pen.
Okay, all right, no problem.
Oh, it's
So, yeah.
it's that one. Yes.
Oh, okay. Maybe I'm not sure how many slides do you have left, because I see.
Okay.
So I see that there are some questions. So maybe if you can maybe make time to answer at least one question. So maybe the one example. So I'm not sure if you're gonna finish all of them, but there is a question that maybe someone needs you to revisit one example.
Okay, like just now or after the session, because I'm just gonna do
Yeah.
one more example.
Yeah,
Okay.
just after. Yeah, you can finish.
Oh, okay. Thank you. Thank you. So let's continue. So the co-interior angles, so angle D and F are co-interior angles. So the sum is going to give us 180. So the easier way to remember these corresponding alternates as well as co-interior, the easier way is fun. Fun, this part over here is called is for corresponding angles. And then this part over here is co-interior. Co-interior, and then this part over here is the alternate angles. For F, you can find F like this, as long as you can find F like this. What's the most important part? The most important part is these lines over here, the parallel lines. And then this part over here is a transversal. F could be something like this. Even it could be shorter. As long as there's a sign over here that says parallel, then we can use these properties, this corresponding. As well as the co-interior, you could be something, could be facing down. You could be facing down. What's the most important part? The most important part is this part over here, the parallel lines. So which means these parts, the sum of these angles is going to give us 180. As well as N, fun. And N could be Z. You can call N could be Z, could be something like this. As long as we have these parallel lines, then which means these sides are equal. Even if it's upside down, something like this. As long as we have these parallel lines, then which means this part over here is equal to this part. It could be facing down, facing up, as long as these parts over here, the parallel lines are there. For example, let's take a look at example 1. Example 1 says, find the values of the missing variables. Give reasons for your answer. So let's use the information that we have for now, the information that we have. What we can notice over here is these parallel lines. We can notice these parallel lines. And then we can notice Z or N, because if this line over here, if this part says this is parallel, this parallel also goes over here. So which means this line is parallel to this line. So if it's parallel to this line, then we can use the Z or N, which means F is equal to 180, which means F is equal to 180 degrees. Why? The reason is going to be the alternate angles. The reason is going to be the alternate angles, as well as G. G over here, this part over here, G and F, they are alternates. G and F, they are alternates. So which means G is going to be 180 as well. G is going to be 180 as well. So the reason will be alternate angles for A. And then let's take a look at B. Find values for B. So for A over here, the simplest way, what we can notice over here, besides the parallel lines, what we can notice is the rule over here. These are vertically opposites. These are vertically opposites. So since these are vertically opposites, which means A is equal to 102. 102. So the reason is vertically opposite. opposite angles. And then for B, we can see this, we can recognize this, we have F over here. We can recognize this, we have F. This is our F. So since we have F, which means B is corresponding to 102, which means B is going to be equal to 102. So the reason is corresponding angles. Someone would use this method over here, would see it's at a different angle. It's fine if you see it at a different angle. It's fine. Over here, since these lines are parallel, then which means this over here and this over here, they are alternates, which means these are alternate angles, which means once we have A, we know that A is 102, right? And then which means we can find B using alternate angles, which means B is going to be equal to A. What's the reason? The reason is going to be alternate angles. Oh, okay. I think I'm going to stop here, Dr. Dubazon.
All right. Thank you very much, Ms. Kabuza. So that was a nice session. I enjoyed it. So I also hope the students, they enjoyed it as well. So I think we had one person who wanted you to do at least one example. I think one example one.
Yes,
So
it's example
maybe
one from slide 8 or 7.
This
Think
one?
Maybe
Oh,
6.
example
Maybe
one.
slide 7. Yeah, someone did not understand example 1.
Oh, okay, okay. Example one over
Yes.
here. Let's use another. Let's use right. This is a straight line. And then let's call this a straight line. And then over here, we have 90 degrees because it was something like this. Whenever you see something like this, just know that it's 90 degrees. That is 90 degrees, which means these lines, let's call this A, B, C, D, which means the line AB is perpendicular to line CD, which means that's why we have 90 degrees over here. And then over here we have 2x. We have 2x, which means we can notice that this is a straight line. This over here, it's a straight line. This, we have a straight line. Angles 2x and 90, they are both in a straight line, in one straight line. Since they are both in one straight line, then the rule says the sum of the angles in a straight line equals to 180, which means we have 2x and then plus 90 degrees. They have to give us 180 degrees. And then which means we have 2x, and then we can take 90 to the other side of the equal sign. Then it's going to change sign. Then we're going to have minus 90. 180 minus 90 is going to give us 90 degrees, which means we now have 2x. And then we are looking for only x, so we have to divide by 2 on both sides. So which means x is going to be 45 degrees. Another easier method is, sorry to disturb, but another easier method over here will be knowing this. If this is 90, this is a straight line. If this is a straight line and then this is 90, which means this permits you to conclude that this is 90 as well. It permits you to, because they are in a straight line. If we have 90, because the total is supposed to be 180. So if we have 90 on the side, which means the side is 90, which means you could have used another method. Another method, you will say 2x is equal to 90, because you know for sure if the other side is 90 degrees, which means we have 2x is equal to 90, and then divide by 2 on both sides. Divide by 2 on both sides. Then x is still gonna be 45 degrees.
Okay, thank you. I think that's clear enough. I think there's a student who wants to be shown page 11. Maybe they want to see what was in page 11. I'm not sure if they're talking about this slide, but there's that.
This, oh,
Yeah, that page 11.
page 11 is the one with fun.
Yes.
They needed
Maybe-
a clarity.
Maybe they needed clarity.
Okay. So for fun, it's an easier way to remember the corresponding angles, the co-interior as well as the alternate. So we use fun. For example, for F over here is for corresponding angles. Y is for corresponding angles. It says, let's say if we have these two lines are parallel. If these two lines are parallel, and then we have a transversal over here, they are being cast by one line. And then this line, this angle over here is going to be equal to this angle over here. So the easier way is to make F. The easier way is to make F. For example, over here, let me use this example over here. We have a triangle ABC, right? This triangle over here, and then we have this part over here says these lines are parallel. If these lines are parallel, but we can notice something over here. This is F. Let me use another highlight. Let's use pink. So this is F over here. We can notice that this is F, but it's upside down, but it's still F. This is F. So I'm saying whenever you have F, whenever you notice F over here, this part over here will be very important if these are parallel. Then if you have F over there, then which means you have corresponding angles. You can notice by looking for F in a diagram. And then for co-interior angles, you can just look for U, something like this, or U, something like this, or something like this, or something like this. As long what's most important is these lines has to be parallel. These lines has to be parallel, and then these lines has to be parallel, and then these lines has to be, which means this is U. Let's look for an example that has, okay, this one could work. This over here, we're looking for U, right? So this is U over here. These angles are co-interior. Why these angles are co-interior? Just look for U. This is U. This is U over here. So let's say this, let's hope this will be this. This is U. So we are saying you can use U. So you know, if you have something like this, if you have U, then which means 25 plus 2x minus 10 degrees is equal plus plus 45 has to give you 180. Why? Because they are co-interior angles, co-interior angles inside U. So U helps you remember that part over here. And then N, we can find N or Z, N or Z. I don't think there's an example that has N or Z over here. Let's try and look for it. Okay, we have Z. This part over here is Z, N or Z. This, we have this Z over here, this. And then the most important thing is these lines, parallel lines. If we have parallel lines, then which means we have Z. Once you notice Z and parallel lines, then you can conclude that this angle, your angle over here, C and B, they are equal. You can conclude that they are equal once you notice that you have N or Z. I don't know if it's clear.
All right, yes, thank you. It's quite clear. If you guys have questions, please do write your questions on the chat. This is the time to ask for questions. You have about 9 minutes. So you can ask your questions on the chat. Anything that you did not understand. I saw some of you guys saying you're a bit lost somewhere. you can tell us where you got lost, and then your teacher's gonna go back and just re-explain. Okay, they're asking you to please go back to page 14.
Page 14, yes.
Maybe they have a question about how you solved this question.
Oh, okay.
Okay.
Over here, we're going to be using properties. The
Yes.
rules for fun. We're going to be using, remember, fun, F is corresponding, and then U is co-interior, and then N or Z is alternate. So we have to be able to see if we have U or if we have F or if we have N. Over here, what I can notice over here is that since this pass over this line is parallel to this line, if it's parallel and then it's being cut by this line over here, a transversal, which means over here, I do have my U. I do have my U over here. And then which means I have this pass over here, co-interior angles. And then there's a rule that says the sum of co-interior angles is equal to 1/8. It's a rule. So which means these angles, all these angles, because they are in the corner, which means these parts over here, all these angles, and then all these angles, because it says over here, fun, these angles, all these angles, which means 25 in this angle over here, I have 25 degrees. I still have 2x minus 10. They are still in the same corner, which means plus 2x minus 10 degrees. They are still in the same corner. And then the rule says this angle is one angle. This is the one angle. And then plus this angle over here, plus 45. Then the rule says this should give us 108. This should give us 108. And then you have to solve for x over here. You have to solve for x. Just solve for x, take 10 to the other side and then 45 to the other side as well as 25 to the other side and then divide by 2. For y, you have to recognize that this angle over here and then this angle 25, they are all in the same straight line. They are in a straight line because y minus 35 degrees and then 25, they are in the same, they are in the straight line. This is the straight line. They are on a straight line. So which means y minus 35 degrees and then plus 25 is equal to 1/8. What's the reason? Angles in a straight line. In a straight line. And then you solve for y. The reason over here will be co-interior. Co-interior angles. The reason over here. I'm not sure if it's clear enough.
Yes, I think
Yeah.
it's clear enough. So thank you very much. So I see some of the questions that the people are asking. So we're gonna give you our email addresses so that we answer those questions. So maybe I can give Ms. Kabuza's email or give my email so that I can attend some further questions. Or also you can come back later at 12. So for some question and answers. So I know Miss Anita was writing some questions that she will ask later on. So please come back or you can stay for the next lesson, which is grade 10. So thank you very much, Miss Kabuza. So it was very informative session. So
okay. Thank you so much, Doctor.
oh, also just to mention, we're gonna send the slides. So please don't panic. We're gonna send the slides. yesterday's slides and today's slides. So we're gonna send them today. So I think Dr. Majosi, are you able to share your screen?
Good morning. Yes. Do that now.
So Anita, is he audible on your side?
Yes, I can hear him. It's a bit, I think it's lagging.
How about now? Is it? Can you guys hear me clearly?
Okay, now it's a bit better, yeah.
Okay, thank you. We just had a power outage, but I have a backup.
Okay.
Yeah.
Thank God.
I believe right now everyone can see my slides. Yes.
I can see it.
Yes, I can also see the slides.
Okay. Yeah. So, we're gonna be doing some trigonometry for the next hour. So, the lessons are divided into 3 parts. I have part 1, which I believe that most of you guys have covered in term 2. And we have part 2, part 2 and part 3, which I believe that you guys will be doing it this coming term, which is term 3. Yeah. So I'm Dr. Majosi from CUT in Bloemfontein campus. So let's begin. So these are, I'm gonna use these lessons interchangeably as aims of or objectives. Okay, so we're gonna start easy with computation, which is how to use your calculator with trig ratios. And the aim for lesson 2 is solving trig equations for angles between 0 degrees and 90 degrees. And lesson 3, solving triangles. We're going to be looking at lengths of sides, size of angles. Lesson 4, use diagrams to determine numerical values of ratios between 0 and 360 degrees. Last lesson will be cost. So due to time constraints, consolidation or a reviewing of these lessons, we're not going to be looking at that, but I will share these slides with you. So it will be for you after this lesson. Do you guys still with me? Can you hear me?
I'm sure you're audible. I can hear you.
Yes.
Yeah, I had to ask because this tablet it doesn't show me the teams once I've shared the screen, and I don't know the video. Chair, I believe that
Yes,
the video is not showing. Okay.
Yeah, but
No.
we can see the screen and then we can hear you properly.
Okay, perfect. Okay, so references as well I've put in the slides. Okay, so the first lesson is all about computing. So let's start with examples. Example A, let me try to zoom so that you guys can see properly. Okay, so we're going to start with example A. Evaluate with the use of a calculator and round off answers to 2 decimals. Okay, so what do we mean by that? It actually means adjusting a number so it has exactly 2 digits after the decimal point. So here we have decimal commas, so it's one and the same thing. Okay, but technically it's not. Commas are used by Americans. I like to believe we use decimal points, but it's fine. It's fine. You can use decimal point, decimal commas. Okay, so how do we compute sine 36 degrees? Okay, so I will be using the Casio FX -82ZA. It's fine if you use other calculators, but they must have trig ratios: sine, cos, and tan. Okay, so go to your Casio FX. You're gonna punch sine there, followed by 3, 6, and this close bracket and equal sign, and you're gonna have 0.59 or 0.59. Okay. So I'm not gonna do all examples. I will pick, okay, for demonstration, because we have limited time. Okay, so there is a reason why we start with computation, but you will see as we go along. Okay, it looks simple, easy, okay, but you do need the skill of how to use your calculator. So what about number 2? Number 2, cos of 24 degrees over 2. You're going to start with this function on your calculator or option, followed by cos 2, 4, and you close, and you're going to see this downward arrow on your calculator, which will take you to the denominator, and you press 2 and you press equal sign. So this will give you, if you cut or round off to 2 decimals, you're going to have 0.46. Okay, so let me do the last one. Okay, number 3. What about tan square 125 degrees? So this is the same as tan 125 degrees all squared. Okay, so how do you punch this on your calculator? So you start with this bracket. Okay, so you start with this bracket followed by tan, okay, which is your trig ratio, and your inputs, which will be 125. Okay, 125 degrees, and you close with this bracket. You close. So actually, this one, you will notice that if you punch tan on your calculator, if you punch it, it comes together with this bracket. Okay, so this, you have to close it, but this one is by default. This one is not by default. You have to close. Okay, so after closing, remember you also have this one. Yeah, this one here. So you do this one, and then there's going to be a function on your calculator, which is x squared. So actually, it gives you a power 2. Okay, so this is your a function, and a 9 equals sign, and then it will give you this one, 2,04. Okay, good, good. Okay, so I have here misconceptions, which are in notes, 3 of them. So why do we even bother about misconceptions? True learning requires unlearning unflawed ideas. So be careful, okay? So sine of 46 degrees plus 27 degrees is not the same as sine 46 degrees plus sine 27 degrees. It's not the same, okay? And also we have a second misconception. 2 sine of 37 degrees is not the same. It is not the same as sine of 2 times 37 degrees. Okay, the last one, sine 24 degrees plus 1 is not the same as sine 25 degrees. Okay, so this 2 is a coefficient. Okay, this 37 degrees is your input or argument. Okay, so you can't just multiply this 2 and this 37 degrees. And here, first misconception, 46 degrees plus 27 degrees, both are your inputs. Okay, so you can't just split, okay, and have sine 46 and sine 27. That will be incorrect. Okay, the last one, sine 24 degrees, it's its own expression, and you are adding it to 1. So it's that one is not input for sine. Okay, so just be careful. All right. Okay, so I will be having these. Can you do the following? Okay, I'm not gonna do all of them, but you guys, you will have the slides. Okay, so you can use these as practice questions. Okay, so I'm gonna do 1 and 4. Okay, so this lesson is packed. So this is part 1 so far. It's like a revision to you because you guys did this in term 2. Okay, so I will be a bit fast. Okay, we have a lot to do. So tan 76 degrees. Okay, so on your calculator, you're gonna punch tan. Okay, so remember when you punch tan, it comes by default with this. Okay, so you punch tan. It is your first step, and then you punch 7. Okay, second step, you punch 6. Okay, third, fourth step, close, and the last equal sign. Then you will have this as your solution, 4.01. Okay, what about number 4? Okay, it's very important, to know how to use your calculator, as I mentioned. So even here at the university, a lot of students still, take this lightly, and they usually make minor mistakes because they don't know how to use their calculator. So it's very important. So how do you punch all of this at once in your calculator? So you're going to start with this. Okay, you're going to start with this, and second, this. Okay. And then followed by your argument or your input, which is 1, 2, 7. Okay, so you have 1, 2, 7. Okay, so remember when you punch this, you have this by default. So keep in mind you also need to punch this. Okay, so we are done with this part. You don't have to click multiple sign. Okay, so your calculator understands what you guys call it, BODMAS, multiplication, addition or division, multiplication first and whatnot. So you guys remember that order. So your calculator understands BODMAS, but you must be careful how you punch. Okay. That being said, so you want to have tan, okay, 3, right, which is this argument, 3, 2, 3, okay, followed by plus, which is this, and then this 2, and then you punch your course. So by default, you're going to have this, okay, so actually it will be this, yeah, and then your inputs 4, 2. Okay, 4, 2. So now you're gonna punch this downward arrow. It will take you to denominator space, and then you start with 8. Okay, and then you punch sign. Okay, so it will come with this. by default. So you just put 2, 1, and don't forget to put this, and you press equal sign. Okay. So if you do that, you will get this 0.31. Okay, good. Good. So lesson 1 is done, dusted. Now we're going to go to lesson 2. Okay, lesson 2. So lesson 2 is solving trigonometric equations. Right. So let me see. Calculate angles using a calculator, trig equations. Okay, so I'm going to do this with example. Calculate the size of the following angles rounded off to 2 decimal places. So you have tan p equals 0.684. Okay, so remember this is solving trigonometric equations. If I were to take you back, by definition, what do we mean by an equation? It's a mathematical statement that shows 2 expressions are equal. So that's why you're going to have this tan p equals 0.684. Okay, so you have this trigonometric expression on your left and just a number on your right. So you have to solve for this p. Okay, so how do you solve for this p? So actually, we have to introduce what is called an inverse trig function. Okay, so since you have tan input equals this, an inverse trig function. Okay, an inverse trig function. So this does the reverse. So it takes that number, which is the ratio, and returns the angle that produced. Okay, so you will have arctan of tan p equals arctan 0.684. Okay, so this is inverse trig function arctan. So what you do on your left hand side, which is tan p, you also do on your right hand side. Okay, by this. So this arctan tan p will give you just p. Okay, so just be careful. This is not 1 over. Okay, it's not 1 over. All right, so a reciprocal in this case is different than the inverse. Okay, so just keep that in mind. Keep that in mind. So you're gonna have now p. Okay, as you can see here, arctan of tan p is p. Okay, what you did on the left, you do on the right. Now you're gonna have this here, arctan of 0.684, which is 34.37 degrees. On your calculator, you will have to do this. Okay, you will have to do that. So what about number 3? Okay, number 3. Okay, so I won't do number 2. So you're gonna do that at home, but just be careful. Another misconception. You can't divide by 3 from the start. So this 3 is part of input. Okay, of this trig function. So just be careful. All right. So when you do that at home, just be careful. Okay. So let's go to number 3. Solve for theta. Okay. If you have this trig equation, 2 cos of theta minus 10 degrees equals 1 comma 268. Okay, so here you can start by dividing with 2. Okay, because 2 is what? 2 is a coefficient. So you can divide by 2 throughout. Okay, so this will cancel this, and you will have this. Okay, so you're gonna have on your left hand side cos of theta minus 10 degrees equals 1.268 divided by 2. Your right hand side 1.268 divided by 2 gives you this. Okay, gives you that. So another misconception here, or thing that you should not do, you can't just transpose this 10 here. Okay, that would be wrong. So this is part of your argument. Okay, so what you need to do, you have to apply inverse of cos. Okay, the inverse of cos, you're gonna have this inverse cos of theta minus 10 degrees, okay, equals to, remember what you do on the left, you do on the right. So this is your right hand side, which is the same as this. Okay, so your right hand side, you're gonna have a cos of 0.634, right? So this will just give you this input theta minus 10 degrees equals this. But what is a cos of 0.634 is 50.65 degrees. Okay, so you're gonna have 50.65 degrees. Now you can transpose this 10. So you're gonna have theta equals 50.65 degrees minus 10 degrees. Okay, no, it won't be minus, it's gonna be plus, sorry, because we have minus here. So if you transpose, it takes the opposite sign. So now you're gonna have 60.65 degrees. Okay, so this is done and dusted. Trig equations. Okay. Let me not erase. You guys might ask questions later. Okay, let me not erase. Okay, so we have this again. Can you do the following? Okay, so I'm gonna leave this to you. Okay, I'm gonna leave this to you. Just 3 problems. Okay, just 3 problems. So now let's go to the next lesson, solving triangles. Okay, so we have this example 1. Okay, so you guys remember this symbol, huh? It means a triangle, right? So in a triangle FUN, FN is 15, and angle U is 90 degrees, and angle N is 28 degrees. Calculates the length of UF. So this is the geometry of this statement. So you have this angle. So this side is 15. Remember that this longest side is called hypotenuse, and then you have a side opposite this angle, and the side adjacent. This angle is what? It's not given. Huh? Yes. So you are required to calculate the length of UF, which is the side opposite 28 degrees. Okay, so side UF is opposite to 28 degrees, and FN is the hypotenuse side. Trig function you're going to use. So you know side opposite to angle, you have to use sine. Okay, sine 20 degrees equals opposite. Okay, I'm gonna write O short for opposite, divide by A short for hypotenuse side. Okay, so you have what? A hypotenuse side, which is 15 here. 15. So all you need to do is to cross multiply. So you have invisible 1 here. So you're gonna times sine 28 with A, and then your O, which is the side opposite 28 degrees, is UF. Okay, so you're gonna have that UF equals to sine 28 times 15. Okay, and this will give you 7.04. Okay, so keep in mind you have to know how to use your calculator. Okay, start with 1, 5, sine, and so on, and then you punch your equal sign, and then you're gonna have 7.04. Okay, easy, super easy. Okay, the second example, calculate the size of angle X in the diagram. Okay, just because it's now a letter, it doesn't mean it's different. Okay, this X can be any value. Okay, actually we want the value for this X. Okay, so we have 28, okay, which is side KL, and we have 12.8, which is side LM. Okay, so this is a right angle triangle, so you can use trig ratios. So you have the side opposite, this angle X, which is unknown, and this side, which is adjacent. Okay, so the information that you have, it's opposite side and adjacent side. So that gives you what? Tan. Okay, so tan unknown angle X is equals to side opposite this angle X divided by side adjacent to this angle. So now you're gonna have 28 divided by 12.8. Okay, you know how to punch, you know how to use your calculator. Now you're gonna have 2.1875. Okay, so remember we want to isolate this X. So we have to use the inverse for tan. So you're going to say arctan of tan X. So this will give you X, right? So that's why our left-hand side from tan X, if we apply arctan, we have X. Okay, the right-hand side, we also have to apply this inverse. So it's going to be arctan of 2.1875, which gives you this 65.43. Good. Okay, so this is our angle, which is unknown X. Okay, so this is your homework. Can you do the following? Okay, this is your homework. All right. So now let's move to another lesson. Okay, the time is running quick. I still have part 2 and part 3. Okay, so define trig ratios in terms of the Cartesian plane. Right? So the Cartesian plane for trigonometry is divided into 4 quadrants with interval 90 degrees. Okay, as you can see here, we have this. Okay, and then we have this arrow. This arrow, it tells you that we measure angles in an anti-clockwise direction. Okay, but we start from 0 degrees on the positive horizontal x-axis. So this is positive horizontal x-axis. So we have first quadrant, which is between 90 degrees, which is between 0 degrees and 90 degrees. As you can see, 0 here, and 90 here. Okay, and then we have what is called second quadrant, which is between 90 and 180. Okay, we have, so this is first, second, and we have third, which is between these angles 180 and 270. And we have fourth quadrant, which is between 270 and 360. Okay, so why do we even bother doing this? You know, why do we have uh, why do we have to do with Cartesian plane from the first place, or what is Cartesian plane? So this is a flat, two-dimensional surface used in maths to map out points, lines, and shapes. So this helps us to visualize. Okay, so problems are best solved if we visualize them. Okay, so keep that in mind. So this bridges the gap between algebra and geometry. Okay, so something to note: 0 degrees and 360 are at the same point, as you can see here. Starting or ending points are the same. Okay, so can you say in which quadrants will the following angles lie? The first one, 39 degrees, lies in where? First quadrant. What about 132 degrees, second quadrant? What about 3, 4, 6 degrees, fourth, here somewhere? 101 degrees, second. 271, fourth quadrant. 89 degrees, that will be where? In second quadrant. Okay. So now we're going to go to how to draw sketches, triangles in the Cartesian plane. Okay, so remember, this is geometry. Okay, it is geometry. Now we are trying to visualize trigonometry in this two-dimensional surface. So, so we're gonna have this triangle in the first quadrant. Okay, so we use the coordinates of the points r, axis to y. So draw a line from the origin, which is here. Okay, 0 is to 0 to the point r. So forgot r here. So that distance OR, this OR distance, is called the terminal arm. Okay, OR, that is the radius of the circle through R. Okay, so now draw a perpendicular line. Okay, so that is after drawing this line. So now draw a perpendicular line from R to the x-axis to form a right angle triangle. Okay, so the angle that OR makes with the positive x-axis is theta. This one here. Okay, is theta, and is always measured in an anti-clockwise direction. In the case here, this angle is between 0 degrees and 90. So hence the sketch is in the first quadrant. Okay, so we are going somewhere. Okay, so we have visualized this triangle in the Cartesian plane, so which is this one. Okay, so first quadrant, angle between 0 degrees and 90 degrees. We have x. Okay, we have x, which is positive. So keep in mind, we are going somewhere with this. So it's actually moving in the direction of the past diagram. I'm going to tell you what it means. Okay, so first quadrant, 0 degrees, the angle between 0 degrees and 90 degrees, we have x, which is positive, y positive, and this r is positive. But what about the trig ratios? So sine theta is y over r, So this the sign will be positive for cos theta, will be positive for tan is positive. So all ratios here are what? Positive. If you move to the second quadrant, so your triangle will be on the second quadrant. So here your x is negative, is on the left. Your y is positive, r is positive, sine theta will be positive, cos theta will be negative. Why? Because you have x, which is negative, and your r is positive. So you're going to have negative. So why is r always positive? Because your r is length, radius. So it won't be negative, okay? So tan theta will be negative. Third quadrant, x is negative, y is negative, r positive, sine theta is negative, cos theta will be negative, tan theta will be positive. What about fourth quadrant? X positive, y negative, r positive. So your sine theta will be negative because it's negative divided by positive. That gives you negative. Positive divided by positive for cos theta is positive. For tan theta, you have negative and positive, which is negative. Okay. So just to refresh you, if we go back with trig ratios, if we take any point R in the Cartesian plane, it is noted that sine theta is what? Opposite of hypotenuse, which is y over r. Cos theta, it's adjacent over hypotenuse, x over r. Sine theta is y over r. Okay, so let me quickly do one example. So remember, we are going somewhere to a cast diagram. Okay. So here, use the diagram to determine the value of R. So equal R. So super easy. You use Pythagoras theorem. Okay. So you're gonna say R squared equals X squared. Yeah. R squared equals X squared plus Y squared. And you're gonna have R squared equals 5 squared plus 12 squared. Okay, so this right hand side gives you what? 169. Okay, but this is equals to R squared. So you want just R, not the R squared. So you're gonna have to take the square root of this, which will give you 18. Okay, so what about sine theta? Sine theta is easy, it's just ratio. We have 12, which is y. We have 5, which is x. Okay, we have r, which we calculated to be 13. So sine theta is y over r, 12 over 13, easy. Tan theta is just tan theta all squared. Work out tan theta first, which is y over r, which is 12 over 5. Now you square, if you square 12 is 144. If you square 5, 25. Now you're going to have this. Okay, super easy. So you can do this on your right hand side as your homework. Okay, so now we are here. Okay, we are here on cast diagram. Okay, so the cast diagram is a crucial memory tool. Okay, that tells you whether trigonometric functions are positive or negative in each of the 4 quadrants of the Cartesian plane. So it ensures you pinpoint the correct angle when solving trigonometric equations. So after this, we're going to go to trigonometric equations. Okay. So the following diagram shows the signs of x, y, and r, as well as the signs of the 3 trigonometric ratios in each of the 4 quadrants. So remember what we did. We have in first quadrant, sine theta is positive, cos theta is positive. So actually all are positive here. Okay, so this is the summary of what we did in the previous slide. Okay, second quadrant. Okay, just keep in mind of the signs. Third quadrant. Okay, negative, negative, positive. Fourth quadrant, negative, positive, negative. Okay, so we summarize this in the so-called cast diagram. Okay, I will tell you what the letters mean. So A, S, and T are they indicate which ratio or ratios are positive in each quadrant. So in the first quadrant, we're going to denote it A, the letter A, meaning all trig ratios are positive. In second quadrant, only sine is positive. So we're going to use S, short for sine, is positive, and all other ratios are negative. In third quadrant, tan is positive, okay, and all other ratios are negative. What about the last one? So cos is positive and all other ratios are negative. Okay, so the so-called cast diagram, also referred to, if we have Cape Townians, here all stations to Cape Town, so remember. Okay, so let's quickly, so here it's a typo, it's quadrant. Let's quickly do this one. So tan theta, in which quadrants are tan theta positive? That will be what? So remember the first quadrant, all are positive, so it's going to be 1. Okay, and which quadrant? 3. Okay, what about part B? Sin theta less than 0 and cos theta less than 0. Which one? So where sine is negative and cos is negative, which quadrants? It will be quadrant 3, right? So they're both negative. Sine theta and cos theta, both negative. What about positive tan theta and positive sine theta? That will be quadrant 3. Tan is positive. No. That would be quadrant 1. Sorry, that would be quadrant 1. All are positive. All are positive. Sorry about that. All are positive. What about d cos theta negative? And the angle is between 0 and 180 degrees. So that would be the second quadrant. Okay, we have negative cos here, right? And this quadrant is between what? 0 degrees and 180 degrees. Okay, so all this, I know I have been just talking and doing some minor examples just like this. It's minor, yeah. But it all leads to this here. Okay. So if 5 sine theta minus 4 is equals to 0 and theta is between 90 degrees and 270 degrees, determine without using a calculator the value of cos squared theta. So it all leads to what? A trig equations. I know we started with trig equations, but it did not need this information. It was easy, but now it's a bit complex, not hard, but you have to use geometry to solve. Okay, so it all leads to this. Okay, so the cast diagram helps you to solve trig equations. So something to note, when the problem says without using a calculator, it means using a sketch. You have to visualize it. Okay, so 5 sine theta minus 4 equals to 0. Write the trig equation in standard form. Okay, so you will have to isolate sine theta. So you will have to divide by 5 both sides. Okay, it's from here. Okay, so you're gonna have sine theta equals 4/5. Okay, but you know by definition that sine is what? So the side is opposite to theta, and this is hypotenuse side. So you draw a sketch. Okay, draw a sketch. Okay, but you have to determine in which quadrant this triangle falls to. Okay, so in which quadrant is sine theta positive? Because this is positive, right? Positive 4/5. In quadrants 1 and 2, this is where you use cos diagram. Okay, so in quadrants 1 and 2, okay, which quadrants are included in the given interval? Okay, be careful. This interval 90 degrees to 270 degrees. So quadrants 2 and 3. Okay, so this angle has to be in quadrant 2, as it is the quadrant which is in the specified interval, as well as where sine is positive. You see now where you need this cos diagram. Okay, so you're gonna have this geometry. Okay, draw your Cartesian plane. This is in second quadrant. Your angle here, right? This is a right angled triangle. Okay, so keep in mind you are required to determine without using a calculator the value of cos squared theta. So we have visualized this, and now we want to work out cos squared theta. Okay, so we have R, we have Y. Okay, but to get cos theta, not cos squared theta, to get cos theta on its own, we need this length adjacent to this angle theta. So we're going to use Pythagoras theorem, r squared, x squared, y squared. Okay, so you have to isolate x. Okay, so if you isolate x, you start by transposing this y squared. So we're going to have x squared equals r squared minus y squared. So what is r? Is 5, y is 4. So we're going to have 25 minus 16. Okay, but we don't just want x squared, we just want x. Okay, so keep in mind that this is x squared. Okay, so what is 25 minus 16 is 9. Okay, this is x squared. X is plus or minus 3. Okay, but what value do we take for x? It's negative, since this is in quadrant 2. Okay, so now we have x. We can work out cos theta. Cos theta is x over r. Keep in mind, we want cos square theta. So cos theta is x over r, which is minus 3/5. Okay, but we are required to find cos square theta. So it will be x over r all squared. So this will be what? 9/25. Here we go. Okay, done and dusted. You see, it takes this is not a lot. It will appear as if it's a lot, you know, because it's bits and pieces that you have to remember, like the cast diagram. But trust me, it's not a lot. You have to know the cast diagram. You have to visualize this. It's not as hard. Okay, it's not hard at all. So this is reviewing what we did. You guys can do that on your spare time, okay? And you have your homework here, and I have references here. So this is part one. I was hoping I was gonna finish the entire thing, but I have part two, okay? But I will share all the slides, okay? So part two, I believe that you guys will be doing this after your break, 10-3. Yes, 10-3, okay? So the outline is as follows. Define and draw three basic functions, okay? Explore the effects of A and Q. I'm going to tell you what that is, and you have your summary and references there. So, you remember the class diagram, okay? Important facts. Okay? This is to remind you, but it's still fresh. Huh? So I don't need to go all over it again. Can you use your calculator to determine the following? Okay, very important. Why is it important? For drawing of graphs, you will be required to compute, you have your input x, so you are required to compute sine x according to your x values, okay? So keep that in mind. Okay, so let's start. You start by trying to complete the table, okay? So you have x 0 degrees, your output, which is y, so you just use your calculator, put 0 here, and then you're gonna have your output as 0. Okay, what about 30? X is equals 30 degrees. What is your output? 0.5. Okay, and so on. 90 degrees is going to be 1. 120, 0.87. 150, 0.5. 180, 0. 210 minus 0.5. 240 minus 0.87. 270 will give you output minus 1. If your x is 300 minus 0.87, 380 minus half, 360, it's 0. Okay, so now how do you visualize this function? How do you visualize this function? So this is a trigonometric function. Okay. So this one, it describes, so all trig functions, they describe the relationships between the angles and the sides of a right-angled triangle. Okay, so we want to visualize this. So this, as you will be, going up the ladder on your grades, varsity, trig functions, they appear in nature, waves, sound and so on. Okay, but we're not there. This just starts. Okay, so how do you visualize this trig function? Okay, so you have to plot. Where do we start? To start here, 0. Okay, so remember what we did here. We have our table. We start with this first point. It's here. The second point, 30 is to 0.5. So this is 30 here, and you have 0.5 there. And then 60 is to 0.87. You see how it moves? 91, 120. See how it moves? See, plots all your points, but we are guided by this restriction. So x is between 0 degrees and 360. It's included. So we start here and we stop here. Okay, so we will have this graph. Okay, so this is a visual for y equals sine x. But there are things that we have to define here. Okay, there is what is called amplitude. So amplitude is the coefficient. So here you have invisible one is coefficient of this trig function sine x. Okay, so it is one. So what do we mean by amplitude? So amplitude is maximum height from the x-axis. Amplitude is always positive. As you can see here, we have before visualizing amplitude. Okay, so these notes will be shared. Okay, so don't worry. And then what do we mean? Oh, it's 10 already.
Dr.
Yes.
Oh, yes, Dr. Majoz. So I think what is left, then we can share with the students.
Okay.
And if
All right.
yeah, and if they have questions, then they can just ask it in the chat, and then we'll answer them.
Okay,
So
no
thank
problem.
you.
Thank you so much.
Thank you very much. So thank you very much. That was a lovely lesson. So I enjoyed trigonometry again. So thank you for that. So for those,
thank you.
So if you have questions, then we'll answer them just during the next session. So even Dr. Majozu can still answer you on the chat box. So if you have any question, then you can type it there. So also remember, at 12, we have some lucky draws. So as Dr. Majozu was teaching, so he was mentioning some few things that are important. So some of those things, we pick them up. So we're going to ask you some of the things that he was talking about. So I hope you were paying attention and taking the notes. So I think right now we are ready for the next speaker. So Anita, who do we have next?
So next up, we have a session for grade 11's trigonometry. It's going to be delivered by Mr. Sboniso Mzulwini. I think he is already here. He is an academic. Yeah, he's an academic from Nelson Mandela University. You can start sharing your screen so you can see that everything is fine.
Okay, let me just share now.
All right.
Can you hear me loud and clear?
Yes, we can hear you loud and clear, and we can also see your slides.
Okay, perfect.
All right, over to you then.
Thank you. Good morning, students and colleagues. So today I will be presenting to you grade 11 trigonometry. As I've been introduced, my name is Sboniso, surname is Mzulwini. I'm an academic at Nelson Mandela University. And I will just be taking you through some of the things that you have went through in your term 1 and term 2 of 2026. I'm not going to focus much on things that are being discussed in terms 3 and 4 because you'll just be confused by those. So I'm just going to focus only on the things that you have already looked at, but then discuss them in terms of problems and some of the questions that you will see in your final assessment in grade 11. So I'm just going to go into full screen mode. If there are any questions or comments, you can just please write them in the chat. We'll come back later on to them and have a look at them and try to answer those. Okay, can you please confirm if I'm on full screen mode now on your side?
Yes, you are on full screen mode.
Okay, thank you. Right. So I'm going to be looking at the following types of problems, which are common problems that appear in your assessments. Hopefully in June, you've seen already some of these problems, as well as in your final year papers. They're also there, so I'll talk about them as well. So we're going to solve the following types of problems. When you are given values of trigonometric ratios or inequalities, sometimes it will be a combination of the two, whereby you're given an inequality as well as an equation, and you are required to find the value of a given expression using the information that is given. We're also going to use reduction formulae to simplify or evaluate given expressions. We're also going to simplify given expressions without using a calculator. That also involves reduction formulae. Then we are going to solve some trigonometric equations and find their general solutions, as well as answer some questions using graphs. Okay, so let's start from this one. So here I have a question that comes from one of the papers in the Eastern Cape from November 2024. And the question is as follows. If you are given this equation here that we have, as well as that inequality, okay, those two, they involve trigonometric ratios involving an angle beta. You have -3 tan beta minus √5 being equal to 0, as well as an inequality of sine beta less than 0. Okay, so when you are given such information, a question like this normally involves, or is going to involve, some sketch that you're going to have to draw to figure out where the angle you are talking about is in your Cartesian plane. Is it in the first quadrant? Is it in the second quadrant, or third or fourth? Okay, because that will allow you then to be able to find out other trig ratios involving that angle that you are looking at. So for example, in this case, we have, as I said, this equation and this inequality. Before we even get to what we are required to compute, let's just work with these two and figure out where is our angle beta in the Cartesian plane. Okay. As you can see here, the equation itself is not written as trigonometric ratio or tan of beta equals to a constant. We want it to be in that form. So that's our very first step. Make sure that if an equation is involved, it is of the form tan beta is equals to a constant. Sometimes it will be sine of some angle or cosine of some angle equals to a constant. So we want to write that as follows. So they have solved for tan beta, or make tan beta the subject of the formula. And what you're going to have is you're going to have -3 tan beta equals to √5. Taking -√5 from the left to the right hand side, and then you're going to solve for tan beta, which is going to be equal to divide by -3 on both sides. So here you're now going to have minus the square root of 5 over 3. Okay, and then here I'm just also going to write the other condition, which is that inequality of sine beta. So here we have that sine beta is negative. So both these conditions here that you are seeing, they describe to you where the angle beta is in the Cartesian plane. Which quadrant does the angle belong to? Okay, so you can see here in your first condition, which is an equation, you have there that tan of this angle is negative. Okay, so tan beta is negative, as well as sine of beta is negative. Okay, so that happens only in one quadrant. Okay, so we need to figure out which quadrant is that. Okay, so we're going to do the following. we're just gonna draw a sketch here, Cartesian plane. Let me just write it like this. Okay. So when you want to figure out where your angle is, first start with your first condition. Your first condition says that tan of beta equals to a negative number, and we know that tan would be negative in two quadrants only, which is quadrants 4 and 2. Okay, now go to your second condition. Second condition says that sine of beta is negative. So sine is negative in two quadrants only, and that is quadrants 3 and 4. So you can see that both conditions are satisfied there in the fourth quadrant. So that means that your angle beta has to be in the fourth quadrant. Okay, once you know where your angle is, so we know that our angle is here in our fourth quadrant. Once we know where our angle is, we can then go to the equation and then say, okay, if our angle is here, that means here we're gonna have our right angle triangle. Okay, if beta is an acute angle, which is there, okay, if that is beta, then tan beta equals to minus √5/3. Now we know that when you are looking at tan an angle, then you're looking at the opposite over the adjacent side of a right angle triangle. So here, because we are in the fourth quadrant, we know that side, that on that side x is positive. So the side that's going to be negative here is the opposite side. So adjacent has to be positive because there is x, and then the opposite side is going to be negative because there is y. You can see here that you are below the x-axis. So we're going to have minus √5 here. Write that clearly, minus √5, as well as there we are going to have, because we have minus √5/3. So the adjacent side then is going to be positive, which is 3, because here you have minus √5/3. Okay, the opposite side to the angle will have to be negative because your triangle is below the x-axis where y is negative. Okay, and the adjacent side has to be positive because you are on the right hand side of the y-axis. Okay, so that's what we have here. Okay, so the length from here to here is 3 units, and the length from there to there is √5 units. But because we are below the x-axis, that's just going to be minus √5. Okay, now once you have those two, you're not done yet. Okay, because we are looking at the sides of the triangle, we know that this side is 3, that side is √5. Now what we want, the length of that side is √5. Now what we want is the hypotenuse side, and to find the hypotenuse side you have to use the Pythagoras theorem. Okay, if we call it maybe R, then we know that R squared has to be equal to x squared plus y squared by the Pythagoras theorem. And then to calculate R squared, we substitute what x is. X is positive 3 and y is negative √5. Okay, but because that's a length of a triangle, we're just focusing on the triangle, not whether it is below or above the y-axis. You can just write √5 the whole squared. Okay, and then you solve for R. Okay, remember R is just a distance from the origin. So when you calculate that, it's going to be positive square root of 14, because it's going to be 9 plus 5, which is 14, and then apply the square roots on both sides. Okay, and that's going to give you the square root of 14. Okay, you can start by saying plus or minus, and then conclude here that R equals to positive square root of 14, because R is just length. Okay, now that you know R, here you have the square root of 14. Okay, now once you have all of this information, then now you're in a position to be able to answer that question that they have there. Okay, so what you are required to do here is to determine the value of this expression here. Sine squared beta minus cos squared beta with the aid of a diagram. Well, that's what we've done. We've drawn our diagram here. And so the last thing to do now is to find the value or evaluate the value of sine squared beta minus cos squared beta. So let's do that. So we're gonna have sine squared beta minus cos squared beta being equal to. Okay, now sine beta, you just read it from the triangle. It's going to be opposite over hypotenuse. So it's going to be root 5. Or it's going to be negative root 5 because our triangle is below the x-axis. So you're going to have minus root 5 over root 14 all squared minus, and then here we're going to have 3 over root 14 because that is cosine is adjacent over hypotenuse and you have a square there. And so if you evaluate this expression that we have here, you should be able to get minus 2 over 7. Okay, so for this type of a question, whenever you're given something like this, the very first thing to do is to draw a sketch, because you have to find out where your angle is, or in which quadrant does your angle lie, and then after that you draw a sketch that we will be able to use to find all your trig ratios of the angle that they are referring to, because that then is going to allow you to be able to write down whatever expression or calculate the value of whatever expression they've given. Okay. Right. Now here's another question, which is from November 2023, paper 2. It's a very similar question to the one we had before, except that now you are no longer given an unknown angle, but the angle is known that you are given here. What you are given that is unknown is just that constant P. So here you are given that sine of 32 degrees is P, and you are required to express each of the following in terms of P. Okay, now we know where the angle 32 is. The angle 32 degrees is in the first quadrant. So once again, here you are required to draw a sketch. So we're going to draw a sketch here. We know we are working in the first quadrant because our angle is 32 degrees. Okay, so that's our angle of 32 degrees. This is going to be our right angle triangle here. Since the angle is known, we have 32 degrees there. We can also write down what that angle is. That angle has to be 58 degrees because the sum of those two angles, or the sum of all those three angles, has to add up to 180 degrees. Okay. Now, if we have sine of 32 degrees being equal to P, now P is the same as just P over 1. Okay, so we know that sine of an angle, when we're in a triangle, that equals to opposites over hypotenuse. So here our opposite side is going to be P, and our hypotenuse side is going to be 1. So one thing that is left for us to find now is the adjacent side. And again, to find the adjacent side, similar to what we did before, we have to use Pythagoras theorem because we have a right angle triangle there. So let us call this side x for now before we find out what it is. So when we use Pythagoras theorem, it's going to be r squared equals to x squared plus y squared. R squared, r is just 1. X squared is what we are looking for, or x, then plus p squared. So when you're solving for x squared here, you're going to have 1 minus p squared, and then x is going to be plus or minus the square root of 1 minus p squared. But then we are working on the right hand side of the y-axis, so x is positive there. So we're going to have x equals to the square root of 1 minus p squared. So in the place of x, then here we have the square root of 1 minus p squared. Okay, so now we have all the details in our triangle that we're working with here. So now we can answer whatever questions that follow from this. Okay, so in other words, we can write the following expressions in terms of P. So let's see what's the first expression that they want us to write in terms of P. Okay, so they want us to write tan of minus 32 degrees in terms of P. Okay, so let's do that. So here we're gonna have tan of minus 32 being equal to, now if you use reduction formulas, which you must have looked at in term 1 or term 2, tan of theta and tan of minus theta, where theta is an acute angle, would be equal to minus tan of theta. So that's the reduction formula that you're going to use here. So here we have minus tan, because 32 degrees is an acute angle, you're going to have minus tan of 32 degrees here. Okay, using this. Right, now once you are here, this then becomes minus. Now tan 32 degrees, you can then come back and read it from the triangle here, what it is, okay? So this is the angle that we are working with, 32 degrees. Tan of that angle will be opposite, the side opposite that angle, over the length of the side that is adjacent to that angle. So we have P over the square root of 1 minus P squared. So then here we have P over square root of 1 minus P squared. Okay, so then that is the expression in terms of P. That is the expression of tan of minus 32 degrees. Okay, let's look at the next one. What about sine of 418 degrees? Okay, so here we first gonna have to deal with this angle here, or we're gonna write this trig ratio in such a way that the angle is an acute angle, which is related to one of the angles here in this triangle here that we have. Okay. So when you look at this angle that you have here, you can see it's bigger than 360 degrees, which is 1 revolution. So we can write that angle by removing 1 revolution from the angle that we have here. Okay, so this is sine. Okay. If you look at 418 degrees, this equals to 360 degrees. Plus 58 degrees. Okay, so we can write 418 as 360 degrees plus 58 degrees, which is simply just sine of 58 degrees. Okay, because sine of 360 plus theta, where theta is an acute angle, this just becomes sine of theta. Okay, so that's what we are using then in this case. Okay, now once you have that this is sine of 58 degrees, you can then go back to your triangle and then look at sine of 58 degrees. Now there's the angle 58 degrees. You have that angle there. Sine of that angle would be the opposite side of that angle, which is the square root of 1 minus p squared divided by the hypotenuse side, or the length of the hypotenuse side, which is 1. So there you will have the square root of 1 minus p squared divided by 1, which is just the square root of 1 minus p squared. Okay, and there you've written now your sine 418 degrees expression in terms of p. Right. So now we're going to move on to another question which involves reduction formulas. This one here. Some of the questions that you'll be given will look like this, whereby you're required to solve an expression without using a calculator, or simplify it without using a calculator. Okay, so in this case, you have to know a lot of things that you did in grade 10, as well as some reduction formulas that you have learned in terms 1 and 2. Okay, so here we're going to look at this problem and just try and simplify the expression that we have as far as we can. Okay, so there's your expression. We have cosine 42 degrees times sine of 48 degrees minus tan of negative 45 degrees all squared divided by cos of 132 degrees all squared. So the very first step is to try and write everything that is a square in this form, because then you can deal with what is inside the square. Okay, so that's going to be equal to, okay, so because here in these two we already have acute angles, we're not going to do anything to them yet. Okay, we have positive acute angles there that are in the first quadrant. Let's not do anything to them yet. Let's deal with these two. Okay, so when dealing with these two, let's start with minus 45 degrees and see what that's going to give us. So here we're going to have remember, before we have seen already that if you have tan of negative theta, that this is going to be negative tan theta. Okay, so we're going to use that reduction formula here. This is going to be minus tan of 45 degrees all squared. And then here we're going to have all over. Then now we use another reduction formula here. Whenever we have that angle, if we have, okay, first of all, you have to realize that the angle is in the second quadrant, the angle that you have here, cos of 132. And we know that An angle in the second quadrant can be written as 180 minus some angle theta. Okay, so you have to write 132 degrees as 180 degrees minus some angle. And that angle here in this case is going to be 48 degrees. Okay, so we have 132 degrees being equal to 180 minus 48 degrees. So here we're going to have that this is then cosine of 180 degrees minus 48 degrees, all of this squared. Okay, then here we're going to apply a reduction formula because we know that cosine of 180 degrees minus theta, that then becomes minus cosine of theta, because in the second quadrant cosine is negative. Okay, and that's what we're going to have there in our denominator in our next slide. So now you're going to have that this is equal to cosine of 42 degrees times sine of 48 degrees minus. Now there we have negative tan of 45 degrees. We know tan of 45 degrees that it is equal to 1. So here we're going to have minus 1 all squared. Okay. Remember, 45 degrees is one of those special angles. Okay, so its trig ratios are known. And then we're going to have cos of 48, okay, minus cos of 48 degrees all squared. Okay, now that's going to be equal to cos 42 degrees times sine 48 degrees minus 1, because you're going to square the negative 1, getting positive 1, but then you have a negative outside there, you still have to multiply with that. So you're going to have minus 1 there. This is divided by square minus cosine of 48. You're just going to get cosine of 48 degrees all squared. Okay. Now, when we are here in this step, you can see that each and every one of our trig ratios inside them, you have a positive acute angle. Okay, so we cannot simplify this any further by using reduction formulas. Okay, or maybe the standard ones that we are used to. But if you look at what we have here in these two factors here, sine of 48 degrees and cos of 42 degrees, you have the following. We know that cos of 90 minus theta that equals to sine of theta, and we also know that sine 90 minus theta that equals to cos of theta. Okay, and that's exactly the reduction. Those are the exact reduction formulas that you can use here. You can use this one if it's going to lead you somewhere, or you can use that one if it's going to lead you somewhere. Okay, now I'm going to change sine. Let's change cosine into sine. Okay, so here, this is cos of 90 degrees minus 48. Degrees, because 90 degrees or 42 degrees equals to 90 degrees minus 48 degrees. Okay, so that times sine 48 degrees minus 1 over cos 48 degrees all squared. Okay, so now this is going to be equal to sine of 48 degrees times sine of 48 degrees minus 1 all over cos 48 degrees all squared. Okay, sine times sine 48, the angle is the same, so we have a square there. So we're going to have sine of 48 degrees all squared minus 1 over cos squared of 48 degrees all squared. Okay, but there is a very popular trig identity which says that sine squared theta plus cos squared theta equals to 1. So from there, I know that minus cos squared theta equals to sine squared theta minus 1. Okay. So when I have sine of 48 degrees all squared minus 1, I can replace that with minus cos squared 48 degrees all over cos squared 48 degrees. And those two, cos squared of 48 degrees over cos squared 48 degrees, it reduces to -1 because those two, they divide each other. And then you have cosine of, you have -1 as the final answer. Okay, so this is one another question which you will see a lot, or a type of question that you would see a lot, whereby you're required to simplify without the use of a calculator. Okay, normally in these questions, the calculator will give you an answer, but the way that the marks are awarded in showing how you get to the final answer, not just the final answer. Okay, so you have to be able to do that. Right. Another question that you will see a lot is a question involving solving trig equations, whereby you're required to find their general solutions. Okay, so here's one question like that. Here we're required to determine the general solution of that given equation that you see there. Okay, so how do we go about solving that equation? Well, here, there's no one way to solve it. There are multiple ways to solve it. For example, I can write sine squared as 1 minus cos squared x, or I can write cos squared x as 1 minus sine squared x, or I can transpose one term to the other side and divide by cos squared to get tan squared. Those are all the things that I can do. Okay, but I'm gonna do this one. I'm gonna just say first write sine squared as cos squared. Okay, so I'm gonna write that 1 as that sine squared x as 1 minus cos squared x. And I'm gonna have minus 3 cos squared x equals to 0. From there, I'm gonna have 1 minus 4 cos squared x being equals to 0, meaning that cos squared x then equals to 1 over 4. Okay, then from here, you get that cosine of x is plus or minus 1 over 2. Okay, so you end up with two solutions. You have 1 over 2 or cos x equals to minus 1 over 2. Okay, now you solve for x by taking the first solution So you take this one first. So for cosine of x equals to 1/2, you have that x will equal to the following. Okay, now cosine there is positive, and cosine is positive in two quadrants, either quadrant 1 and quadrant 4. Okay, so there are two solutions there. You either have, so you're gonna have x equals to, if you look at arc cosine of 1/2, you're gonna get 60 degrees. So that's gonna be 60 degrees plus 360 degrees times constant k. K is an element of integers, or you're gonna have x equals to, here you can have minus 60 degrees, because it's gonna be minus that angle, because that's how we write angles here in the fourth quadrant. Okay, minus your acute angle, or you can write it as 360 degrees minus 60 degrees, and then plus 360 times k, where k is an element of integers. Okay, and this is going to be 300 degrees plus 360 degrees times k. K is an element of integers. So these are the two general solutions for cosine of x equals to 1/2. But you're not done, because you also have this one. So now you have to work with that one. Now for cosine x being equal to minus 1/2, you have the following. Okay. Now where is cosine negative? And here cosine is negative in the second quadrant and in the fourth quadrant. Okay. Now an angle in your second quadrant, that will be 180 minus arc cosine of 1/2. So you have x being equal to 180 degrees minus arc cosine of 1/2 will be 60 degrees, because we've calculated it there. Okay, then plus 360 times k, where k is an element of integer. So this will be 120 degrees plus 360 degrees times k, where k is an integer. Okay, you're not done, because you've only covered the second quadrant. Now you need to cover the fourth quadrant. I mean the third quadrant. In the third quadrant, an angle there is written as 180 plus your reference angle. Okay, so let me just squeeze that one here. Or x equals to 180 degrees plus 60 degrees, 360 times k. K is an element of integers, and then lastly you then have them. That's going to be 240 plus 360 times k, and k is an element of integers. Okay. So now those are all the solutions for your equations, your equation or your general solution. So you either have this x equals to that, or x equals to that, or x equals to that, or x equals to that. Okay, so those are all then your general solutions for each and every case that you have here. Okay. Right. And now I think we're going to look at one last type of a problem that you may see, or that you will see in your assessments. And it involves solving or finding solutions using graphs. Okay. Now, at this point in grade 11, I assume that you know how to sketch trigonometric graphs, including the ones that have been translated or ones whereby there has been a change that has been made to them. Okay. So for this question again, we have we are given two functions, f, which is sine of 2x, and we have g, which is tan of x minus 1. And here we're required to draw the graphs of f and g on the same set of axes. And it is specified where we must draw them. So for x values that are from minus 45 degrees all the way up to 180 degrees. Again, as I said, I'm assuming that you already know how to sketch these graphs. So if you sketch the graphs and you have your diagram, it should look something like this. Okay, where f is the blue graph and g is the red graph. Okay, let me just indicate here the asymptotes for the red graph. It has to be at 90. Okay, there is your asymptote. That vertical line there. Okay, as you can see, we are sketching from minus 45 all the way up to 180 degrees. You're not required to draw from minus infinity to positive infinity. Okay, right. Now, there are questions that involve or questions that require the use of a graph for you to be able to answer them. Okay, and here in this example, we have the type of a question. Here we're required to sketch, but then in these following questions, you are required to use the graph that you have to answer these questions. Okay, so here we're required to determine the value of x for which in 6.2.1 we have sine of 2x is greater than 0, and in 6.2.2 we have that the product of f of x and g of x is greater or equal to 0. Okay, so how do we go about answering these questions? Well, we're going to have to use our graph here. So for sine of 2x is greater than 0. Remember, sine of 2x, this is nothing but just f of x. So what this question is really asking you is that from your graph, find out where f of x is greater than 0. For what x values is f of x greater than 0? Okay, what this means in your graph is that find out for what x values will the graph of f be above the x-axis. Okay, so we go to our graph and then we're gonna start from minus 45 degrees and go along our x-axis until we get to 180 degrees then. Okay, and what we want there is we're gonna take all the x values whereby the graph
Hello, Swanny. So are you still with us?
Oh yes, I think maybe I had a disconnection.
Oh, okay.
I'm still here. I'm still here.
Okay.
Okay. Thank you. Thank you for checking. I was wondering what is happening now. Okay. Now, as you can see that as I'm coming from minus 45 degrees all the way here, you can see that the graph is below the x-axis, so I don't take those x values. But you can see that once I reach x equals to 0 degrees, the graph is on the x-axis, but immediately I pass x equals to 0 degrees, then the graph of f is above the x-axis all the way until I get to 90 degrees, where now the blue graph is on the x-axis, and then when I pass 90 degrees, you can see that the graph is now below the x-axis until I reach 180. At 180, it is on the x-axis. So the x values then that you are looking for are these ones here. Okay. So from just after 0 degrees all the way to just before 90 degrees. Okay. So how do you write that then in terms of in a correct mathematical form? You will say x is an element of or you can write it as an interval and just say from 0 all the way up to 90 degrees. Now here we use round brackets because 0 is not included, or we don't take 0 here, as well as we don't take the end of the interval 90 degrees. So we go from just after 0 and we end just before 90 degrees. So these then are the x values that you are looking for. Okay. You can say here x is an element of, or you can write like this. Okay. For the second question, what about the second question? Now you want f of x times g of x to either be positive or equal to 0. So this is actually two conditions. Okay, you have f of x times g of x greater than 0, or f of x times g of x equals to 0. So either one must be satisfied. So we're looking for values of x whereby the product of f and g is positive, or the product of f and g is equal to 0. Okay, remember, whenever a product is 0, that means at least one of the two is 0. Okay, here a product will be greater than 0, meaning positive, if both these two are negative, or if both of them are positive. Okay, so for this first condition here, you're looking for where the graphs of f and g, either both of them are above the x-axis or both of them are below the x-axis. Okay, and for this condition, you are looking for everywhere, or all the values of x whereby at least one of them equals to 0. So f can be 0, or g can be 0, or both of them are 0. Okay. Now let's go back to our graph and read where those values are of x. Okay. As I start from minus 45 degrees, I can see that both of the functions are below the x-axis, meaning they are both negative. So their product will be positive. Okay. All the way up until I reach 0. Okay. Now, when I'm at 0, I know that once one of them is 0, then the second condition is satisfied because the product of the two now is going to be 0. So then that means here I take all my values from minus 45 to 0 degrees. Okay. The values after 0, you can see that now f is above, which means f is positive, and g is below, which means g is negative. So the product there won't be positive, but it will be negative because one value is positive, one value is negative. Okay, that happens all the way up until we get here when g becomes 0. Now, once one of them is 0, we take that x value because we know that the products of the two will be 0. And then here now, both of them are above the x-axis. So their product will be positive all the way up until I get to 90 degrees. So this is 45 degrees here. Okay, all the way up until I get to just before 90 degrees, because at 90 degrees, one of the functions is not defined. If one of them is not defined, then the product can't be defined. So we can't talk about the product if one of them is undefined. So we just skip that value there. Okay, at 90 degrees. And then you can see that after 90 degrees, they are both below the x-axis. So their products will just be positive because they are both negative. All the way up until you reach 180, because at 180, f is 0 or one of them is 0, then their products will be 0 then. So our values of x then that we are looking for, we start at minus 45, go all the way up to 0, we include 0. Then after 0, we don't want those values until we reach 45 degrees. Then we start taking those values of x from 45 degrees all the way up to 90 degrees. We skip 90 degrees and then we continue after 90 degrees. Then we go all the way up to 180 and we pick up 180 degrees. Okay, so the values that you are looking for then have to be the following. You have minus 45, change the color here. We have minus 45 degrees less than or equal to x, less than or equal to 0 degrees, which covers that first part. And then the second part will be from 45 degrees exclude 90. And then begin after 90. Then we go all the way up to 180 and we include 180. So x is either within that interval whereby the endpoints are included, or x is within this interval where the lower bound of the interval is included, but the upper bound is not included. And then or x is here, whereby the upper bound is included, 180, but that lower bound is not included. Or you can write it like this: x is an element of square brackets minus 45, because we include 45 to 0 degrees union with 45 degrees to 90, exclude 90, union with 90 all the way up to 180 degrees. Square brackets. Okay, I think I'm gonna end here. Because of time, I'm gonna now take any questions that students may have.
Thank you very much, Sbonis. So that was on time.
Yep.
Yeah.
So is there anyone who has a question regarding what was covered today?
There isn't any question in the chat now, but we'll just wait just 1 minute and see if there's any student is gonna pop up a question.
Yeah, so
No
which
problem.
which also means it was a nice and clear lesson.
Exactly, very practical.
Oh, they are
Yeah.
very confused. They don't even know what to ask.
No, it can never be that.
Yeah, just also you guys must remember that we're gonna be asking you some questions at 12. So some of the questions that we can ask are the ones that will be extracted in this lesson. So if you don't have questions for us, we'll have questions for you.
Okay, I think there's a question actually in the chat. Someone is saying they missed the drawing of the tree graphs section.
The drawing of the two graphs.
Yes, I think so.
This one. Yeah, no,
Yes.
I didn't draw the graphs. I just used a sketch because that was the intention. It was not to draw graphs because drawing graphs is covered in grade 10 in detail. So here I just wanted to only answer questions from graphs or using the graphs.
Oh, okay. Thank
So
you.
it
But
was
the slides are gonna
intentional.
be okay. But the slides are gonna be sent to the students so they will be able to just use the graph to just answer the question.
Yes, 100%. The slides are going to be sent to them.
All right. Thank you so much for that.
Okay, let me stop sharing now.
Okay. So now we are going to move to our last section for grade 12, trigonometry also. It's going to be delivered by Mr. Manaka. He's an author of a book called Mathematics Made Easy. So you know for sure that you are going to be in good hands. I'm not sure if he's in already.
I think he's in. So, Mr.
Oh,
Manaka,
okay.
you can try to share your screen in the meantime.
Yes, please.
All
The
right.
students are going to
Good
receive the slides today. There was a question in the chat.
Yes.
All right.
Yes.
morning, everybody. Can somebody confirm if you can hear me?
Yes, we can hear you.
Awesome. Awesome. Just moment, I'll share my screen. I'm not sure if you can see my screen.
We can't see your screen.
Yeah, not yet.
Okay. All right. Just a moment. Even now?
Yes, nothing.
Oh Lord. Will be some signal delay, but I am on it. I believe now should be to everybody.
No, we're still not getting anything.
Okay, let me stop sharing and reshare again.
Okay, I hope that helps.
And apologies for the delay. I don't know what's the problem, but I'm resharing my screen for clear visibility. Somebody confirm, please.
So I'm not sure. Maybe it is lagging. The screen is lagging because we still don't see anything.
Because on my side it shows you are sharing a screen.
So let me just check.
I also turn on my camera. Can you see my face right there?
No, we also can't see your face.
I have used another option. I believe you can now.
No, we can't see anything. I think the audio improved a bit, but not the.
Even my Windows doesn't appear. But if I were to show you what has just on my side, everybody should be seeing my screen, should be seeing everything around.
No.
No.
Can you maybe try sharing? Have you showed your presentation? Because it does show that you're sharing your screen, but then it just appears blank, like just white. So maybe if you click on your presentation.
Okay, just a moment. Yeah, okay. Hello there. May you
Hi.
confirm for the last time?
Yeah, we don't see anything. Okay.
Now it's
You don't-
showing.
Yes. Now we're good.
Oh, okay, apologies. Good morning, everybody, and any other person in the meeting. This is Bishop. I'm your host today. From TTN, Tis the Nation. Okay, Bishop is a math and science teacher at Eagles View Christian School in Gauteng. Anyway, sorry for delay. Just the system was not responding the way I want. All right, this is Bishop once more again. We'll be dealing with the trigonometry. All right, try means trigonometry. So this looking at the study of an angle actually. So I'm just gonna quickly remind you some few important concepts before we can attempt some questions. See this other picture that I've just attached. Before I can go there, there's a bow tie. There's a red wearing a bow tie. I cannot find the source. Just a moment. I'm trying to see where is my bow tie. There's no way I can do my trigonometry without having the bow tie included. Okay, I'll just reshare my screen again just a moment. Just a moment.
Mr. Manaka, are you still with us? All right, so it seems like we're having some technical difficulties, so apologies for that. We will try to fix it as soon as possible.
Yeah, maybe while we're okay. Let me just check what Mr. Manaka is saying. Okay, we can wait for him a bit. So apologies for that. So maybe in the meantime, Mr. Mzulwini, did you finish all the things that you wanted to cover on the grade 11 slides since it overlaps?
I did finish everything on on the slides that I was using.
Okay, all right.
But
No
I'm
problem.
but I'm still here. I'm happy to answer any questions that students may have.
Okay, all right.
Great slides. I doubt Dr. Majosi is still in the call. Because there's a person who's complaining proposing that they didn't finish the grade 10 slides, but I don't think Dr. Majosi is still around.
He is.
He is.
I am around. But yeah, I've left work. I am at home, so electricity is fine here. So just give me about a minute, and then I will. Yeah, I will be with you.
Okay, thank you. I appreciate that.
Awesome. Can you please confirm if you can still hear me, see my board? My system is stabilizing gradually, and apologies for the delay. Somebody confirm if you can hear me and see my screen. I need your key confirmation.
We can hear you, but you can't see your screen.
You cannot see my screen. Okay, just a moment. My system is now operating a bit better compared to before. Okay, confirm if you can see my screen.
Yes, we can see your screen now.
All right. Okay, apologies once more again. My system was responding better than I thought. Okay. Without any waste of time, I'm just gonna run through my presentation. All right. Part trigonometry. Trigonometry is divided into 6 sections. I'm just gonna list them. It is divided into 6 sections of trigonometry. The first one that I want everybody to make sure you don't mess around, it is reduction. And I'm gonna show you the craziest way on how do we deal with reduction. Number two,
Mr. Manaka, sorry, if you can just click on your board because we're just currently seeing participants. So the screen that we're seeing is on the participants.
okay. All right, just a moment. All right, which screen do you see now?
The meeting, so it's on the meeting screen.
Now it should be my board, I believe.
No. We are not seeing it.
Okay.
Yes, that's perfect now.
Okay, I think now we're seeing. Yeah.
All right. Okay. My time is almost up. All right. But second part is to look at the quadrant. I call it trig hence the quadrant. Number three, we're gonna look at the identity. I'm just gonna try to make sure that I cover all the aspects that I've listed. Number four, we have 2D and 3D. Number five, we have what we call general solution, which is now linked to the graph. So these are the 6 parts of trigonometry. So if we can mess around this part, the whole of trigonometry is out. So hence part of trigonometry. Okay, I'm just gonna start with the quadrant now, just to list more. All right, this is my traditional board. Okay, whenever we talk about quadrant, I call it trig board. And every time when we have to represent the quadrant, there's an image that I like to use for my head wearing a bow tie. So I couldn't have time to put it here, but I'm just gonna make my demonstration. So whenever we talk about the bow tie, every time we represent the angle or the triangle, there is a certain way that we like to draw them. We don't just draw them obliviously. There are a certain system that we use. When we represent our triangle, we draw them in this format. And if you can look whatever I'm doing, it looks like a bow tie. Hence, I like to put a red wearing a bow tie. And this is our first quadrant, second quadrant, third, and the fourth quadrant. Okay, this will be my angle. I'm just gonna use a color code for variation. This is my angle theta there as it goes. Please understand, in the first quadrant, this is my hypotenuse, opposite, and adjacent. So I'm gonna use X, Y, and R. So in the first quadrant, all X, Y, and R are positive. But coming to this second quadrant, R is positive, y is positive, but my x in this quadrant, it is negative. Moving to the third quadrant, my y value, it is negative, my x remain negative as well, but my r, it is then positive. Moving forward to the fourth quadrant, my y become negative, r is the hypotenuse, which is always positive. So the keynote when it comes to quadrant, we're going to be using the theorem of Pythagoras. These are the keynotes. We're gonna be using our Pythagoras. R squared is equal to the x squared plus y squared. But in all the cases, our R remains positive. We cannot have hypotenuse being a negative. So we'll be looking at x, we'll be looking at y on a triangle. But when we look at x, our x will be equal to plus or minus the square root of an answer. Y plus or minus, then quadrant will determine whether the x is positive or negative. Even when it comes to y, it will be the same system. Y will be equal to plus or minus the square root of a particular value. The plus or minus will be determined by the quadrant. And also, please don't forget to use our trig ratios. We have a trig ratios which are studied from grade 10. We have sine, cos, and tan. So there is a common acronym that we like to use, SOHCAHTUADE. What is that sine? It is opposite. It is opposite over the hypotenuse. Cos, that's an adjacent over the hypotenuse. Lastly, which is tan, in full is tangent, by the way, and that will be opposite over adjacent. These are our three things that I would like us to remember before we can go to the application. Please don't forget our R cannot be negative. R is always positive. So that's the first thing that I would like to remind you, hence a trick bow. I'm just going to try to get the picture for my bow tie so that you don't forget. Okay, number two is to quickly talk about the reduction. I'm just going to move, almost touch all the parts, reduction. Reduction, allow me to compartmentalize my board. Reduction. And the main reason is, why do we reduce? Why do we reduce? That's the first question I'm going to ask myself. Why do we reduce instead of using the question as it appears? We want to make all the angle and acute angles. We want to deal with an acute angle. So when you talk about an acute angle, we are talking about the angle that is less than 90 degrees. That's why we want to read. There's a system that I like to use when it comes to reduction for using a calculator usage. For example, let's see here. I'm just going to show you how to use a calculator. But the question will come without the use of calculator. Hey, use the calculator. As long as examination doesn't come with a camera, please use a calculator. All right, check something here. Let's say we have sine 180 minus theta. And probably in exam, you forgot which quadrant is this. Don't stress. Let me show you something. This is good for knowledge purpose, but when it comes to exam, we don't have to impress any marker, but get all the answer done. The first quadrant, that's our reference angle. So in the second quadrant, 180 minus theta, moving forward, 180 plus theta, and that's how that will be 360 minus theta. Okay, if I were to list my system, that's 0, that's 360. We keep on adding 90. Okay, keep on adding 90 degrees. Gonna go to 270. You add 360. This is where sine is positive, tan is negative, cos is negative, but it's just in the first quadrant. All three ratio are positive. So whenever it is sine 180 minus theta, oh, I mean a second quadrant. That's where sine is positive. Let's say this is an exam. You forgot. I got you. Check here. In exam, you forgot about this thing. It's exam pressure. You might even forget what you know. Use a calculator. And the question is how? Wherever you see theta, where you see theta, I call it an angle. Where you see theta, please replace it with 1. I'll explain this. Every time I see theta, I'm going to replace it with 1. Okay, that will be sine 180 minus 1. Can everybody on your calculator tell me the answer? Is the answer positive or negative? Please, I'll be reading my comment section. Is the answer negative or positive? I just want to read the comment. Let's just work together. Sine 180 minus 1. Is the answer positive or negative? I'll be reading the comment. I want to see your response. Use your calculator. Don't hesitate. You bought it for a reason. Is the answer negative or positive? I want to see the answer only. Anybody with a calculator, may you please assist me? Just say sine 180 minus 1. Answer. I'm interested in the answer you get, but the sign. Your answer will be positive. That's where you know, oh, sine 180 minus 1. That will be positive sine theta. You don't have to stress the marker. Get the marks as you keep on moving. Let's prove if this is correct. What about tan? Let's see. We need to be lenient and smart in exam. No need to waste time. So let's just prove it with tan. Tan 180 minus theta. Wherever you see theta, please put 1. That will be tan 180 minus 1. The only thing that we want to know whether your answer is positive or negative. So tan 180 minus 1, your answer will result into a negative numerical value. We are not interested in the answer but the sign. So tan 180 minus theta, that will be negative tan theta. You are done. You don't have to keep on. In case you forgot this is good for knowledge purpose, but when it gets to exam, we don't have time to play. We keep on collecting the answer as we go. But now, here's the situation. Somebody can ask me, say, what happened if now they give us something that here on the quadrant? Just like example, let's see. Let's say now, examiner gives you sine theta minus 180. It doesn't look like something you know from the quadrant. So here's what I want to tell you now. Here's the key. When it doesn't look, when it does not look like what you see in the quadrant, quickly, please add 360. If it doesn't look like what you see in the quadrant, you simply add the 360. How? That will be sine theta minus 180 plus, I'm just going to change my color code for variation, plus 360. Oh, okay, that will be sine theta minus 180 plus 360. That will be positive 180. Oh, you can now rewrite it well. That is sine 180 plus theta. You are done. And what is sine 180 plus? Sine 180 plus, if I go back to my quadrant, sine 180 plus, it is in the third quadrant. And in the third quadrant, that's where tan it is positive. So it means all the sine and cos are negative. Quickly, your answer will be equal to negative sine theta. Let's say you forget about this quadrant. Don't stress. Use a calculator. Replace theta with 1. You don't have to stress about this. For you to add this, it doesn't have a mark. So examination doesn't come with a camera. So use your camera. That will be sine 180 minus 1. Use a calculator. Or plus 1. Sorry. Use a calculator. Your answer will be a negative 0, comma something. We are not interested in the numerical value, but the sign. Don't ever, ever, ever make examiner to make your life difficult. Please don't ever make examiner make your life horrible. Okay, moving forward here, few things that I would like us to check before we go to questions. There are certain rules that we're gonna use when we prove identity. Allow me to just create a fresh page. Allow me to create a fresh view and see a good system here. If you can put this at your back of the notes, you will never miss any question when it comes to proving identity. There are certain systems that I've set for proving identity. Number one, we have two principles here, the main and the major principle. First thing is to remember your first question identity, which says that tan theta is equal to sine theta over there cos theta. Second one, 1 over tan theta. That will be is the same thing as I divide this by 1 and I now reciprocate. So that will be cos theta over sine theta. Please don't try to mix these two identities. Don't try to mix these two identities. These are the two principal identities. Number 2, square identity. Sine squared theta plus cos squared theta is equal to 1. We call it a square identity, but it doesn't end here. We can make the sine squared theta being the subject of the formula, and that will be 1 minus cos squared theta. My dearest people, I want you to see this behind. This is the difference of two squares. Many of you might have not been aware, but I'm going to show you something. This is the same thing as 1 minus cos theta, 1 plus cos theta. It is a difference of two squares. Don't see it as minus cos squared theta. It's also a difference of two squares. Same applies to our cos. Cos squared theta is 1 minus sine squared theta. Remember 1, I can put it as a square. 1 squared, it is 1. Hence, a difference of two squares. A squared minus b squared. That will be a minus b, a plus b. It is a difference of two squares. In some cases, when you are simplifying, you might get stuck please change it to a simplified vision. That will be 1 minus sine theta, 1 sine theta. Then you are done. These are the two principal identities. But the main question learners tend to ask me, so how do we actually prove it? How? All right, let me just give you a few writing up. How? Number one, change the complex identity into simpler form. That's the first thing. If I'm given tan, I have to change it to sine over cos. Hence, change the complex identity into the simplified form. Number two, you are allowed to simplify. This is the main thing I like to emphasize. You are allowed to simplify both sides. In some cases, you will be tempted to simplify both cases. So can I say you are allowed to simplify both sides simultaneously? Spelling simultaneously. Okay, I need OUSY. All right. You are allowed to simplify both sides simultaneously until you arrive at a common simplified. Until you arrive at a common simplified. Okay, I'm still on holiday. My spelling is error. Simplified. Simplified state. I'll explain what do I mean. In some cases, you might prove the right hand side, but you're not reaching the left hand side. So you are allowed to simplify both sides simultaneously until you arrive at a common simplified form. But here's what I want to warn you. I know what you're going to do. Please solve or simplify each side independently. All right. I know you're going to solve them at the same time because of the word simultaneously. Please solve or simplify each side independently. Independently. Okay. Rule number 3. There are about 5, but I'm going to give you 3 or 4. Number 1, change the complex identity into the simplest form. You are allowed to simplify both sides simultaneously until you arrive at a common simplified state. Do not solve or simplify each side. Please solve each side independently. Number 4, start from a complex side. Start from a complex side. Number 4, I thought I would 3. Number 4, apply rules of algebra. Apply rules of an algebra. Okay, for now, we're just gonna work with these 4 rules. I'm just gonna grab a question now and we see if all the rules will make sense to us. Let me see if we have any proving identity question. Okay. I just got this question now. I haven't gone through them before, so this will be my first attempt with you. All right. Proving identity format. I'm just gonna zoom it in for clear visibility. Okay, looking at this question, it looks so. This is nice. Okay, this is nice. All right, can we try this together? The first thing that I'll do, I'm gonna check the complex side. Just gonna divide my board. I'm gonna look at the complex side. Basically, this is my left hand side. That's only complex left hand side. So I want to prove that the whole of this is equal to. Please anticipate your answer. So it means if I arrive at sine theta over cos theta, I'll be done. Okay. Let's see. Okay, I don't know, but together we don't have to mess around. We're gonna apply the system. All right. The second that I see it is sine. I'm gonna write my sine as it appears minus. Wait, I see tan. Every time I see tan, I change it to sine over cos. Okay, tan. I now see the light. I see where I'm going. But because there is a negative involved, I would like to put a bracket. That will be sine theta over cos theta. Multiply by, okay, I see cos squared theta. It is fine. Don't just make things difficult for you. Cos squared theta over 1, because I'm put it as over 1. Down there, wait. I forgot this. I'm gonna make it rule number 5. I was afraid to tell you this, but I'm now forced to. Rule number 5. I'm just gonna move these things a little bit up. I just have to move it a little bit up. Just up a bit. Just up a bit. Okay, just up a bit. I want to squeeze number 5 in this slide. All right, number 5. Rule that you are allowed to change 1 into sine squared theta plus cos squared theta. You are allowed. Every time you see 1, not every time, at some cases where I'll show you. Every time you see 1, you can change sine squared theta plus cos squared theta. And whenever you see sine squared theta plus cos squared theta, you are allowed to change it to 1. That's one of the 5 rules that I was waiting to give you. Number 5. Let's see here. What I see right there, I see that's what catches my attention. I see what catches my attention. It's fine. Let's see. That will be cos theta minus. Every time you see a minus to the brackets, I can change 1 into sine squared theta plus cos squared theta. Oh, plus sine squared theta. Up to so far, you are sitting over 2 marks. By changing this, there is a 1 mark guarantee. by changing 1 into this, another 1 mark. So out of 4, you have 2. You can submit your answer sheet and leave. In case you don't want to do memorandum, you can just leave it and say, ma'am, I don't want to do a memo for you. I'm leaving the other marks for other kids. All right, let's see now. What I see here, I have cause and cause. I like to do this. In my most cases, I see this is a cos squared theta. I like to do this. I can break it down, lots of exponents. A squared is the same thing as A times A. So cos squared, I can change it into cos theta times cos theta. You are allowed. Apply the rules of algebra. But I see something here. We are now multiplying this. Let me use this. This will cancel this. They're multiplying. They will take care of each other. So I'm left with what now? Let's see. We are left with sine theta minus sine theta times cos theta. I hope you're okay with me because they take care of each other. So going down, every time we have a bracket, we have a minus involved, we do the bracket. So this negative will multiply everything inside. So I'm going to have cos theta minus sine squared theta minus cos squared theta plus sine squared theta. I believe we are still on the right track. Okay, what I see down there, sine minus sine positive, they will also take care of each other. So what am I left with? Okay, I'm just going to move it to this side. I am now left with this. Sine theta minus sine theta times cos theta. I already see my answer done, but let's see. In the denominator, I have cos theta minus cos squared theta. All right, what can we do? All right, let's check here. Let's check. I have sine, I can take sine as a common factor. I have cos and cos. Oh, okay, I see something. I'm gonna take my sine as a common factor. I'm gonna left with 1 minus cos theta over down there. I'm gonna take cos as a common factor. That will be 1 minus cos theta there. Wait, ta, ta. What am I left with? Sine theta over cos theta, which is this examiner was too nasty. I'm glad we got it. Perfect, perfect, perfect. Any other question? Anybody's lost? Please let me know. I just enjoy myself. I don't know about you, but I'm enjoying myself at this point. I hope I'm not losing anybody or leaving any other person behind. This is nice. This is nice. All right, we have another question that I just saw yesterday. Let's just have some fun. Math is fun. We should just enjoy trick. What is the question? For proving identity. Okay, let's just do 2. Let's just do the 2 questions. 5 marks. Easy peasy. Let's see now. All right. Prove that 1 into 1 minus cos 4x is equals to squared x times cos squared x. I don't know where should I start. But wait, let's see something here. I think the problem here is only this part. It's only this part. Okay. How do we run around this? Okay, the first thing that I'll do is to remind you that we have a double angle. I think the double angle will work for our likings here. All right, cos 2 theta is equal to 2 cos squared theta minus 1. It has 3 babies and is also equal to 1 minus 2 sine squared theta and is also equal to cos squared theta minus sine squared theta. Okay, this is our double angle. It has 3 babies and we have sine 2 theta, which is equal to 2 sine theta cos theta, and this is our double angle. All right, let's see here. Oh, I see something. I think I'm done. Check what I see. Please, please take a note. If I say cos 2 theta is equal to, we can change to any you like, but let's just choose this 1 minus 2 sine squared theta. There's something that I would like you to see, and there's something that I would like to remind you up here. Are you aware that if I say cos 2 multiplied by 2x, that will be 1 minus 2 sine 2x. Please talk to me. I want you to see this. Where's my mark? I want you to see this. This is 2. It's a double here. But when it gets to this side, now a single. But now it is 2 times 2, that is 4. What is half of 4? Hence 2 there. That's a nice application. So what I see now, this is what I see. I'm not sure if it will work, but let's see. Let's see something here. I have 1 over 8 into 1 minus. I can change cos 4x into minus 1 minus 2 sine 2x. Let me do this. I see this question. I love the tone. I can change 4 into, because there's a minus, I'm introducing the bracket. That will be 1 minus 2 sine squared 2x. Examiner was fighting here. Examiner was fighting here. All right, but let's see if we'll reach the answer. That will be 1 over 8 into 1. This minus will multiply everything out. 1 minus, that will be minus 1. 1 multiply negative times negative, that will be plus 2 sine squared 2x. Okay, 1 and 1, they will take care of each other. So I am left with 1 over 8 into 2 sine squared 2x. Not yet. All right, allow me to reproduce my slide. I'm not yet to the answer. True. What can we do here? Oh, okay, check something here. We are not yet to the answer, but I see something here. Check here, check with me. I need you to be with me. What is this? I see something. And I will explain. Sine 2x. Sine 2x. But Here's what I want you to see. If I write sine 2x is equals to what? 2 sine x cos x. That's a double identity. But now it is not just sine 2x, it is squared. Whatever I do on the right should be done on the left. Sine squared 2x is now equals to, and we just expand 2 squared, that will be 4 sine squared x cos squared x. I think we are done. Check here. That will be 1 over 8. Check 1 over 8 multiplied by 2. This is the 2 we have. But what about this? This is equals to that. And that will be multiplied by 4 sine squared x cos squared x. We are done. What is 2 times 4? 8. 1 over 4 multiplied by 8 multiplied by sine squared x cos squared x. 2. This will cancel this. We are left with exactly what examiner wanted us to find. It was, this question is just a little bit of ambiguity, but I love the tone. So our left hand side is equal to, we are done. Examiner was just doing a show off with this question. Not even, this question is just unnecessary. This question is just unnecessary, but I love the tone that the examiner was bringing out. It needed us to do some mathematical operation. It to do some what you call integration of the double angle. Even we have to be squared. All right. I have another question here, but that time won't allow us. Oh, let's look at this question before I sign out. Let's look at this question right here. This is a general solution. I would like to give you about 3 tips before I sign out. I like to give you 3 tips when it comes to general solution. Let me just write it just alongside. When it comes to general solution, here are the tips. Every time you deal with the general solution, there are about 6 tips as well, but I'm just going to give you 3. Number 1 is rule number 1. Never break this rule. Never ever divide. Never ever divide. Never ever divide, except you are going to get sine x over cos x, which is equals to tan. Please never ever ever divide, except you're going to get sine over cos, which is tan. So here is only where you are allowed to divide. Like we have sine 2x over cos 2x. That will be tan 2x. Never ever 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 divide, except you're going to get sine over cos, which is tan. Every time you divide, you are losing the solution. Never ever divide, except you're going to get sine over cos, which is tan. For example, let's say now you have sine squared x. Okay, let me do this. Sine squared x minus sine x equals to 0. This is learner A. Somebody can do this. Somebody can take this to other side, which is fine. Sine squared x equals to sine x. Your problem will come now here. You will be tempted to divide both sides by sine. You will be tempted to divide both sides by sine. So sine x will be equals to 1. And this is absolutely wrong. You are losing the solution. This is absolutely wrong. You are losing this. You are going to get a one solution here. So avoid dividing. We only divide if we are going to get sine over cos. That's why we are allowed to divide. Except these cases, never, ever, 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 ever divide. Only to get sine over cos, which is tan. Oh, my time is up. But before I leave the session, one more question for you to answer for me. I have one more question for you to answer for me. This is how I leave my presentation. Okay, we have sine q over cos. This is just a basic trigonometry. Sine theta. Let's just see something here. I'm leaving my slide. Sine theta over cos over tan theta. But now I replace my theta with q. Sine q over cos q. That will be equals to tan q. Oh, this is me saying thank you all for joining. I'll see you in the next episode. Should I see you again? I'm more happy to see you again. Goodbye. This is Bishop signing out.
Thank you very much, Mr. Manak. So that was a lovely session. So also on time. So thank you very much for that. So I think now for those who are still in attendance, so this is the perfect time to ask the questions. So if you have questions regarding the slides or even on anything about trigonometry, so this would be the perfect time to ask those questions. So I don't see any questions, Anita.
Yeah, I don't see any question. Just someone sharing that he believes that general solutions sometimes give more challenges than other questions. But I'm sure that they got some clarity now, because I think the teacher here did give some tips on how to solve the general solutions.
Oh, yes, he did.
Yeah. Oh, here's a question from Busi Siwe. The question is in the chat. I think she's asking about an equation. I think the equation didn't have a square. So she's just asking about that.
Which question?
It's that question just above the red, the one in red.
Oh, okay. What is that?
The equation in red. I think it's on the screen now.
Yeah, on the same slide that we are seeing. Yeah, that one.
Okay. Yeah.
I think that's the. So she was saying, is it not supposed to be 1 minus 2 sine 2x squared?
1. Yes, there is a 1 here. Let me show you the one. With this way there is yeah, you are right. It is 1. Check here. Remember whatever we have provided. It is 1. Here's our 1. Hence I did the bracket for you to see it well. Here's our 1. Remember the question, we only have 1 from the provided question. So I had to change it to 1 minus. This is the one that I've changed to. And as a result, minus times positive will lead us to -1. That's why we have 1 minus 1. You are right. I did the brackets for 1 minus 2 sine squared 2x.
Busisiwe, is your question answered? Were you asking about that particular equation there or the ones in red?
I've also allowed Busisiwe's mic, so you can just unmute if you want clarity.
All right, yes. Yes, Busisiwe, you're welcome to just ask the question. Just unmute yourself. Don't be shy.
Busisiwe, talk to me. How are you, child? Are you sorted now? Are you okay?
You can turn it off. Like you can turn it on, I mean. Okay, she's saying the option, she hasn't been given the option.
I just can't unmute her from my side, but I've enabled the microphone. It is enabled. If she can try again.
Can you just try again, Busisiwe?
Okay, it might be maybe the way the system is set up on her side.
Okay, but I think she's saying that her question was answered.
Okay, next.
All right, the mic is turned on now. I was just referring to the red parts in the top there. The square wasn't at the red parts, but it was later rectified.
Oh, okay.
Oh,
Thanks.
yeah, okay, no problem. Yeah, I see where you're going. Thank you so much for your input. Is there any person having a question? Let me know before I disappear. If anybody having any question, please feel free to ask me. I'm still on the board. I'm just gonna share this now as a PDF. Or should you want to check some few notes, some tips? I'll just reproduce my slide to the group for note taking.
Seems like everyone is good. There aren't any questions.
No problem. I thank you so much for your time. I'm signing out.
Thank you very much, Mr. Manaka. So I think now we have reached the end of our lessons for today.
Yes.
Yeah, so thank you all for continuing to attend. So I hope maybe there are still some people who attended even from the beginning. Yeah. So, and then we can, I think maybe we can start with the prizes.
Yes.
Yeah. So we said it is a lucky draw. So do we have maybe one person that you can pick who maybe answered the question? And
Also, I should pick someone and give them the question.
Yeah.
Okay. So don't leave, guys, please. Do not leave. Don't run away. I'm going to ask, I'm actually going to start with Busisiwe here. She's been very active. So Busisiwe, I'm giving you a question. Please give me an answer on the chat, or you can speak if your mic is still on. So the first question, or rather the question for you is, okay, so when Ms. Kabuza wrote fun on her slides, which angles was she talking about? what letter, like the letters that white fan, what angles did they represent, each of them?
Okay, the F stands for corresponding angles. The U stands for co-interior angles. And the N stands for alternate angles.
Okay, girl. That's correct. That's correct. You did very well. Thank you.
So before you move on, sorry. So to those that answer correctly or are selected like Busisiwe, can you please send me an email address? You can just type in the chat box. Send an email address that you actively check so that when we want to find out the address for delivery of your prizes, we get to you. So Busisiwe, please on the chat, send me an email address that we'll be able to reach you in.
Okay, so for the second question, we're gonna have you, Siyabonga, to pick someone.
Yeah, so let me check. Let me check who can I pick here.
Okay, I think there's someone volunteering actually.
Oh, okay. So who's volunteering? So I have a question for them.
It's Suranya Sai.
Okay. So Suranya, so the question I have for you is that what did Mr. Manaka say the first step is when proving the identities? So using trigonometric functions.
You can just write in the chat box because I don't think your mic is on.
All the mics should be enabled now.
Oh, okay. You can just unmute yourself and answer your question. Are you with us, Soranya?
Okay, I think she just raised the hand.
No, it's someone else actually who's volunteering. I guess they'll take the third question.
Oh, okay. So, okay, she's saying simplify and
Simplify one or both sides.
So how are we feeling about that question? I mean, about that answer?
I mean, we're not 100%, but you know, it's in the good direction.
Okay, so we give her the
Maybe
prize for that.
Maybe Soranya can try to give us another answer in the same direction that she was headed, but just maybe with more explanation. We're giving Soranya another chance.
If you can simplify, no.
So I think is Soranya still. She's saying that you simplify.
Okay, so how many questions have we done now? I've done one. This was the second one, right?
Yes, this was the second one. So I think we can give Soranya.
All right. So for the we're gonna go to the Soranya gets the second one. For the third one, we're just gonna ask the question and anyone can answer. So people need to be fast.
Okay,
So-
can they lower the hands first? Because I see some hands are up already.
Yes, please lower your hands, guys. We just need you to be very fast. So right now, I suggest you just go to the chat box so that as soon as I ask the question, you just quickly type. So the third question is, if the parallel lines are cut by a transversal, the co-interior angles are called what? I'm just going to repeat. If the parallel lines are cut by a transversal, the co-interior angles are called what? What are they called? We're not looking for an angle. What are they called? Okay. Busisiwe. Busisiwe answered the first question, right? So you're gonna have to wait for other answers. Just answer, guys. We'll see which answer is correct.
Please repeat the question.
The question is, if the parallel lines are cut by a transversal, the co-interior angles are called what? So if you have two parallel lines and then they are cut by a transversal, what are the co-interior angles called? I'm gonna take an answer in 5, 4, 3, 2, 1. Done, guys. I'm gonna take someone. The first person who got it correct is Aradia. I'm not taking Busisiwe because you already answered, I think, the first question. So the correct answer is supplementary, because those angles add up to 180. So now we'll go to the fourth question. Same thing. You should quickly go to the chat box. I'm gonna ask a question and you guys have to quickly type the answer. So the fourth question is, in which quadrant is 10 negative? In which quadrant is 10 negative? Guys, come on. In which quadrant or quadrants is 10 negative?
We have contenders for this one.
Okay, I think we're good for that. We're good. Time is up, you guys. We're good. The first person who answered correctly, can you please help me check? There's a lot. And I don't want to say someone who's already answered, because I see some people are answering while they've already won.
I think the first person is
Nokubonga,
Nokubonga.
actually. Yes.
It's Nokubonga.
Yeah, so it's the second and fourth one, guys, where 10 is negative.
So also Nokubonga, please share your
Email.
email address.
I think that's it for the questions, ne?
I think how many do we have so far?
We had 5 questions. Don't you have 5 people, or am I wrong? Oh, there's one more question.
Yeah, Nokbonga is the fourth person.
Yes, so there's one more question. Guys, this is the last question. So please go to the chat box and be ready. The last question is, Dr. Majosi said the CAS diagram is sometimes referred to as all stations to, what's the last word? It's referred to as all stations to. I need you guys to give me the fourth word. The CAS diagram is sometimes referred to as all stations to. What's the last word? Come on, guys. Really now?
So is Dr. Majosi on in the chat?
Dr. Majosi, are you around?
Because we noted a different answer from him. So
I think he's not around. He'll be so shocked because what? Guys, come on. All stations 2. You guys don't remember, all of you. Okay, at this point, I'm even giving the people who have already answered the chance. Okay. So Untarabile got the answer. It's all stations to Cape Town, guys. So Onkarabile, please send your email. Just write your email down below. So that's it for the questions, but we do have one last person to give a prize to. I don't even know if they're still around. Let me check. Siabonga, please help me check if he's still around.
oh, okay. Let me just check. I'll search his name.
Okay. Imagine leaving when you're going to get a prize.
I don't see him now.
So how are you gonna do this now?
So maybe we can save it for the other day.
For the other?
For the other day. So
Yeah.
to give prizes.
Yeah, I think we'll save this one for the other day. So guys, I think this should be a lesson for you guys to pay attention to every single thing, to listen to what your respective teachers are saying so that you can be able to win some prizes. But I can see that you guys are actively listening because a lot of you guys answered. So that's good. Just keep it up.
So also on Friday, we'll have the lucky draws and competitions. So if you did not win anything today, so
it's okay.
You still can win something on Friday.
Yep.
So please join us tomorrow. So tomorrow we will be covering functions. So we're gonna be starting from grade 8 all the way to grade 12. So
and
anything regarding functions. So even if you have some questions regarding functions, so please jot them down. Then you're gonna ask our teachers maybe at the end of the sessions. So, and also,
and
we
also
have,
something to note. Yeah.
Yeah, we also have careers in mathematics, a segment. So most of you are wondering why we study mathematics and what type of jobs you can do if you study mathematics. So we have 2 guests that will explain some of their careers. So they also did mathematics like you. So please tune in. So is there anything else you want to add, Anita?
No, not really, but I just want to ask, Dr. Skosana, did you get all your emails?
Yes, I am all sorted.
Oh, okay. Then I don't have anything else to say. I think we are done.
All right. Thank you very much for attending, everyone. So we'll see you tomorrow.
Yes. You're welcome to leave the meeting.